नहीं होगा मैम, रोजाना यही करता हूँ।
Link is working. Okay, people are able to join. Are you able to see people join? Can you ask her just to be sure before we start because it was plugged in with the online. I can start. Everyone's still walking. Hello, everyone. If everyone could just settle down, we would like to begin the program shortly. So if you could all take a seat. So hello and welcome everyone. I'm happy to welcome you all to the ITU FAO workshop on Cultivating Tomorrow, Advancing Digital Agriculture through IoT and AI. This event is being hosted by the Telecommunication Engineering Center, TEC, Department of Telecom, Ministry of Communications, India, and the Indian Council of Agricultural Research, ICAR, Department of Agricultural Research and Education, Ministry of Agriculture and Farmers Welfare, India. So a very special thank you to all our hosts for today. I would like to take this opportunity to invite all our dignitaries on the dais for the inaugural session. So first, I would like to call upon Mr. Ajay Kumar Sahu, who's the Additional Secretary Telecom and Ministry Services, Department of Telecommunications, DOT, Ministry of Communications, India. So please, sir, if you will join us. Next, I would like to call upon Mr. Cizo Enoysan, Director of the Telecommunications Standardization Bureau, TSB, at the International Telecommunication Union. Thank you, sir. And next, we have Ms. Tripti Saxena, Senior Deputy Director General and Head of the Telecommunication Engineering Center, the technical wing of the Department of Telecommunications, Government of India. Thank you, ma'am, for joining us today. We will now have Mr. S.K. Chaudhary, Deputy Director General, NRM, the Indian Council of Agricultural Research, ICAR, Department of Agricultural Research and Education, Ministry of Agriculture and Farmers Welfare, India. And last, definitely not the least, we'll have Mr. Sebastian Voss, who's the co-chair of the focus group on artificial intelligence and Internet of Things for digital agriculture. So thank you for joining us, Sebastian. So we will now commence the inaugural session with the lighting of the lamp by the dignitaries. So I would like to invite all the dignitaries on the dais to light the lamp. So we will now begin the Saraswati Vandana. So over to our singers.
जय जय हे भगवती सुरभारती तब चरणों प्रणमाम्यहम्। जय जय हे भगवती सुरभारती तब चरणों प्रणमाम्यहम्। नाद ब्रह्ममयि जय वागीश्वरी नाद ब्रह्ममयि जय वागीश्वरी शरणं गच्छाम्यहम्। जय जय हे भगवती सुरभारती तव चरणों प्रणमाम्यहम्। शरण्या त्रिभुवन धन्या त्वमसि शरण्या त्रिभुवन धन्या सुरमुनिवन्दित चरणा नवरसमधुरा कविता मुखरा नवरसमधुरा कविता मुखरा जय जय हे भगवती सुरभारती तव चरणों प्रणमाम्यहम्। पंकज तनु विमले जय जय हे भगवती सुरभारती तव चरणों प्रणमाम्यहम्। प्रणमाम्यहम् 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 प्रणमाम्यहम्।
So it's special thanks to our local host for organizing that. We will now continue with the agenda for our inaugural session. For this, I would like to request Ms. Bhumika Gaur, ADG Radio TEC, to please welcome Mr. Ajay Kumar Sahu, Additional Secretary and Member Services DOT, with a bouquet. Next, I would like to request Ms. Namrata Singh, ADG IoT TEC, to please welcome Mr. Sizo Inouye-san, TSB Director, ITU, with a bouquet. Next, we will have Mr. Rajneesh Kumar, ADET IoT TEC, to please welcome Ms. Tripti Saxena, Senior DDG and Head TEC, with a bouquet. Next, I would like to request Mr. Nitish Sharma, Study Group Assistant, ITU at the Area Office and Innovation Office, New Delhi, to please welcome Dr. S.K. Chaudhary, Deputy Director General, NRM, ICR, with a bouquet. Next, I would request Ms. Jyoti Sengar, ADET TS TEC, to please welcome Mr. Sebastian Voss, Co-Chair of the Focus Group on AI and IoT for Digital Agriculture, with a bouquet. Thank you, colleagues. We will now have the ICAR Geet or song on display.
जय जय कृषि परिषद भारत की सुखद प्रतीक हरित भारत की कृषि धन पशुधन मानव जीवन दुग्ध मत्स्य फल यंत्र सुवर्धन वैज्ञानिक विधि नव तकनीके पारिस्थितिकी का संरक्षण शस्य श्यामला छवि भारत की जय जय कृषि परिषद भारत की हिम प्रदेश से सागर तट तक मरुधरती से पूर्वोत्तर तक हर पथ पर है मित्र कृषक की शिक्षा शोध प्रसार सकल तक आशा स्वावलंबित भारत की जय जय कृषि परिषद भारत की जय जय कृषि परिषद भारत की
Now I would like to invite Ms. Tipti Saxena, Senior DDG and Head TEC, to deliver the opening remarks. Over to you, ma'am.
Respected Mr. Sahu, sir, Member Services and AST, Mr. Cizo Onyo, and Director TSB ITU, Mr. Chaudhary, DDG ICAR NDA, and Mr. Sebastian Bosse. Very good morning. It is a matter of pride for TEC DOT India to co-host ITU workshop on meeting of focus group on artificial intelligence and Internet of Things for digital agriculture, FGAI4A, today and tomorrow jointly with ICAR, DARE, Ministry of Agriculture and Farmers Welfare. TEC is the national standardization body for telecommunication in India and national inquiry point for WTO TOTBT for telecom sector. TEC has also been mandated to interact with various international standardization bodies like ITU, APT, HC, IEEE, etc. 1-2M is also one of them. TEC has already adopted 1M2M release 2 and 3 specifications as national standards for M2M IoT ecosystem in the country. TEC has released 22 technical reports in IoT M2M arena, covering diverse verticals like automotive, power, health, safety, surveillance, and smart houses, smart cities, smart villages, intelligent transport system, smart agriculture, and IoT security. All the technical reports are available on our TC website. And out of these, ITU has posted the 6 technical reports on its global resource portal under IoT section, recognizing them as insightful resource for the benefit of global community. We are also the nodal authority for mandatory testing. Dear all, today we have gathered to discuss one of the most critical sectors of our country, agriculture. We all know that agriculture serves as the backbone of our society and our economy. providing food and livelihood to billions of people here. However, despite its undeniable importance, the agriculture sector faces numerous challenges that threatens its sustainability and productivity. The issue of small land holdings in many parts of the world, including India, climate changes, erratic weather patterns, extreme temperatures, and unpredictable rainfall have disrupted traditional farming practices, leading to crop failures and reduced yields, making it challenging to achieve economic of scale and increase productivity. In addition to above, the agriculture sector also grapples with the issues related to crop health monitoring, water management, and optimal use of fertilizers. Without proper monitoring and management, farmers risk losing their crops to pests and diseases, while inefficient water and fertilizer uses contribute to environmental degradation and reduce productivity. However, with technology, particularly the Internet of Things, AI, ML, and 5G, we can address these challenges and ensure the sustainability of our agriculture sector. The IoT has emerged as a game changer for the agriculture sector, offering innovative solutions to improve efficiency and productivity. By leveraging IoT devices such as sensors, drones, and smart irrigation systems, farmers can now monitor soil condition, crop health, and weather patterns in real time. This real-time data allows farmers to make informed decisions, optimize resources uses, and maximize crop yields. Furthermore, the advent of 5G technology promises to revolutionize agriculture even further. With its high-speed connectivity and low latency, 5G enables seamless communication between IoT devices, allowing for faster data transmission and more efficient data processing. This means that farmers can access and analyze vast amount of data in real time and enabling them to respond quickly to changing conditions and make data-driven decisions. In conclusion, while the agriculture sector faces significant challenges, technology offers a glimmer of hope for a brighter future. The deliberations in workshop today will explore the latest trends across the globe, how the application of AI, IoT, unmanned aerial vehicles, and other cutting-edge technologies in aiding tasks like harvesting, weed detection, irrigation, and pest identification can revolutionize agriculture. Thank you.
Thank you, ma'am, for the opening remarks that really set the stage for the presentation and the overall workshop that we have ahead. I would now like to invite Mr. Cizo Inoue-san, the TSB Director, ITU, to deliver the keynote address. So over to you, sir.
Thank you, Shuri Tripti Saxena, Shuri Ajay Kumar Safu, and Shuri Suresh Kumar Chaudhary, and Chair of Focus Group, Dr. Sebastian Bass, colleagues and friends. Good morning and warm welcome to you all. It's a great pleasure to be here in New Delhi, and I thank our generous hosts, the Telecommunication Engineering Center, the Department of Telecommunications of India's Ministry of Communications, the Indian Council of Agricultural Research, and the Department of Agricultural Research and Education of India's Ministry of Agriculture and Farmers' Welfare. We highly appreciate your support. India has increased its engagement with ITU's work very significantly in recent years. It's trend to certain to continue. We will meet again in New Delhi this October at the Governance Conference for ITU Standardization, the ITU World Telecommunication Standardization Assembly, WTSA. ITU meetings are welcoming more and more delegates from India. India is welcoming more and more ITU events. And India also hosts ITU's newest area office and innovation center here in New Delhi. This increasing engagement will continue to bring greater strength to ITU, helping our work to reflect your spirit of innovation and focus on the future. With innovations like here digital identity, India has become one of the world's best known case studies of how we can expand digital inclusion at speed and at scale with life-changing benefits. There is so much that the global ITU community can learn from your experiences. And today, we will gain key lessons from your innovations in digital agriculture. The essential value of ITU is that we foster collaborations to support innovation on a global scale. We want new technologies to benefit everyone, everywhere. We examine emerging use cases to understand their technical requirements, and with that understanding, we develop international standards to meet these requirements globally. Today's workshop and tomorrow's focus group meeting are in service of this endeavor. In digital agriculture, we see yet another example of why partnerships receive such emphasis in the UN's Sustainable Development Goals. Digital technologies are transforming every sector of our economies. To take full advantage of the new opportunities for innovation, we need to build bridges between different areas of expertise. Industries are converging, creating associated convergence in regulators' responsibilities. The consensus that we built while developing new standards help us to coordinate this convergence and tap into the full value of digital transformation. That's exactly what we aim to achieve with this focus group on AI and IoT for digital agriculture. ITU and FAO are bringing together our respective communities to help digital agriculture built on firm technical foundations. We want everyone to benefit from innovations, improving the precision and sustainability of farming technologies. We are paying close attention to the needs of developing countries where people's livelihood are most reliant on agriculture, because that's where digital agriculture can deliver the greater gains in sustainability and resilience. I thank all our speakers and moderators and everyone participating today and tomorrow for your investment in this important work. Our work is driven by your contributions and consensus decisions. I applaud you for your commitment. Thank you.
Thank you, sir, for those enriching remarks in our welcome address. Now I would like to hand over the stage to Mr. R.S. Singh, Deputy Director General, IoT, TEC, DOT, India, for a briefing about the release of the technical report on revolutionizing agriculture, the digital transformation of farming, prepared by TEC, and ICAR. So over to you, sir.
Respected dignitaries on the dais, the delegates present here, and those who are participating in this workshop virtually also, a very good morning, good afternoon, good evening to all of you, each and every one of you. This technical report on revolutionizing agriculture, the digital transformation of farming has been jointly prepared by TCA and ICR after in-depth study. This technical report basically will explore concepts of emerging technologies being used in agriculture. It explains various types of cellular and non-cellular communication technologies used in IoT and M2M domain, depending on the coverage, power, specific use case requirements. It will also cover the concepts of artificial intelligence and machine learning, big data analytics, blockchain, digital twin, and metaverse. It also includes components of digital agriculture such as precision agriculture, agricultural robotics, remote sensing and satellite, drones and UAV and their applications. The technical reports also focuses on the international standards in IoT M2M domains such as 1M2M standards, ITOT recommendations, and ISO standards pertaining to the agriculture sector. This chapter also, there is also a chapter which contains various initiatives which have been taken by TC, DOT and TC to facilitate the organized, secure, and sustainable growth of IoT M2M sector ecosystem in India. The reports also highlights various ML algorithms commonly used in predicting crop traits, deep learning models for yield prediction, pest and disease detection, weed detection, soil health management, crop quality management, smart irrigation, and livestock management. The report also has a compilation of various use cases on digital agriculture. This technical report may serve as a reference document for all the agricultural scientists, academia, startups, and other related stakeholders, and it gives meaningful insight of latest technologies being used in agriculture domain for improving the productivity amid growing demand for food. This technical report will be available on the websites of TC and ICR. Now I request the dignitaries on the dais to formally release the technical report. May I request the officers of IoT division of TC and Dr. S.N. Jha, Dr. Anil Rai, and Dr. Ravi N. Sahu from ICR to please join for the group photograph. Thank you. Over to you, Ms. Matthew.
Thank you, Mr. Singh. So now we'll continue with the remaining section of the inaugural session, for which I would like to invite Dr. S.K. Chaudhary, Deputy Director General, NRM, Indian Council of Agricultural Research, ICAR, to deliver the keynote address. So over to you, sir.
Thank you very much. Good morning and namaste to all of you. On the dais, Mr. Ajay Kumar Sahuji, Mr. Sizo, Madam Tripti, Mr. Sebastian. Of the dais, we have dignitaries from ITU, FAO, also international and national delegates, senior officers from TEC, DOT, also senior officers from ICR, especially my colleague, Dr. S.N. Jha, the Deputy Director General of Agriculture Engineering, many directors of ICR institutes, ADGs, and organizing team, also the representatives of press and media. Right in the beginning, I would like to place on record my sincere thanks to ITU and FAO for giving us this opportunity to host the workshop on cultivating tomorrow, advancing digital agriculture through IoT and AI. This important event is particularly important for Indian Council of Agriculture Research because Indian agricultural research shortly going to complete its 100 years. And during the last 4 or 5 years, we have decided to dedicate each year to one of the very, very important theme of national importance. And this year, for us, the theme is digital agriculture. And from that point of view, organizing this 2 days workshop and 1 day special event of ICR on digital agriculture is very, very important for all of us. ICAR, which is called a conglomeration of 113 research institutes, more than 80 All India Coordinated Research Centers, 750 Krishi Vigyan Kendras, and also a big organization with almost 6,000 number of scientists working in that. We consider this as an opportunity to advance the agricultural sector. Therefore, advancing digital agriculture through IoT and AI is our foremost goal, and all of us, all institutions, are very keen to do this. And therefore, in almost all the dimensions, almost all the sectors of agriculture, including mechanization, processing, post-harvesting, horticulture sector, the soil, water, crop, climate, fertilizer, animal sciences, fisheries, also agriculture extension, including the agriculture education. In almost all these sectors, ICAR is doing very frontline researches and accepting, adopting, and implementing, taking use of these tools, IoT-based tools, and all AI machine learning. And we are trying to move ahead and advance the agricultural production quality and also providing good quality nutrition to people in this country. The science of digital agriculture has been gaining prominence with the advent of fast-paced advances in technologies that can impact the process of discovery to delivery of knowledge and goods with smallholder farmers in countries, particularly in South Asia. Considering the challenges in agriculture in India and most South Asian countries and opportunities in advancing technologies, digital ecosystem and recent government initiatives, this 2 days deliberation workshop, as well as tomorrow's your business meeting, as well as the 3rd day event of ICAR, these are the most important event pertinent to useful, keeping in view the advances in communication technology for IoT and artificial intelligence and its potential uses in digital agriculture. India's agriculture sector is of utmost importance because more than 20% of our GDP comes from agriculture sector. And if you see the growth rate by which agriculture is gaining and agriculture is moving forward is itself is appreciable and is very, very important for India's economy to boost in future. As no single agency or institute can take on the entire PA process. Therefore, precision agriculture, which is very, very important for us, we have network project in this line. Almost all the institutes of ICAR in all the sectors, in one form or the other form, they are working on precision agriculture, making India's future very much focused as well as very sound in coming days. This program of national importance is being driven by almost all the institutes of ICR, almost all the sectors, whether agriculture, horticulture, animal science, or fisheries. We are trying to make a dent, and we are trying to take full advantage of this important program. Government of India also has taken several initiatives, and prominent amongst those is Digital Agriculture Mission, which encourages project based on cutting edge technologies like AI, blockchain, robotics, drones, remote sensing, and all. Several governmental schemes and programs have also been introduced, like National Mission on Horticulture, the India Digital Ecosystem of Agriculture, which is called IDEA, which is a framework, and National Agricultural Market, which is called ENAM, which is very, very popular now. In almost all the sectors, the digital agriculture is putting its impact, and a common platform for all agricultural activities such as AgriStack. This is also benefiting the stakeholders, including the farmers and also people who are working in private and governmental organization, particularly in agricultural sector. Data inconsistencies, whether in soils or nutrient and fertilizers, this is of great concerns. It's of great concern globally, and therefore almost all the countries across the globe, they are emphasizing working in this area to improve the situation of natural resources, particularly soil, water, fertilizer. Stakeholders are pushing for the adoption of semantic web technologies like ontologies to improve search engines capability. Additionally, scholars and funding agencies have developed fair data principles to encourage data sharing and reuse. To ensure sustainable technology adoption, data sharing policies and ethics need strengthening. As I said, ICR is a conglomeration of so many institutions and organizations, not within ICR, but we also work, we take support of other departments, other institutions, those working for government as well as non-government organization. And we are extending now and collaborating with many private parties, private partners and private companies, taking help of them and for advancing the digital agriculture in India. One of our dedicated research institute, which is located right here in Delhi, which is called Indian Agricultural Statistical Research Institute, is consistently working in this line and is dedicated for taking advantage of these technologies and making use in agriculture sector, not only in research, but also in development as well, extension of technologies and all. We have Kisan Sarathi portal, which is fully digital in nature, and it provides digital solutions to almost all the stakeholders in this country. The Indian Agricultural Statistical Research Institute also has a special initiative called Krishi, Agricultural Knowledge Resource and Information System Hub for Innovation, which is an initiative of ICAR to bring its knowledge resources to all stakeholders at one place. This is a centralized data repository system consisting of technology, data generated through experiments, surveys, observational studies, geospatial data, publication, learning resources, and all. So the idea of cultivating tomorrow, advancing digital agriculture through IoT and AI workshop is a welcome step for whole India and particularly for ICR. We feel elevated to host this very important event, for which again we are thankful to ITU as well as FAO for considering number one, India as host this time and giving us opportunity, particularly ICR, giving us opportunity to take this today's workshop, in which today there will be workshop and tomorrow will be a business meeting. I'm pretty sure that in a couple of days, a lot of deliberation discussions will take place. Many success studies, stories, and many studies will be shared. Many experiences will be shared, and some focused recommendations will emerge out of these. The recommendations will be of not used to ITU all alone, but we will also take a step forward using this recommendation, and it will help us to take agriculture sector to a new height using the recommendations emerging out of this 2 days deliberation. Third day, our colleagues, our participants, delegates from ICR side, they will be here, and it will be a very broad kind of discussion on third day, and we'll be looking forward to take advantage of discussions, deliberation which are taking place today and tomorrow, and pave a path and find out some way forward for ICR and ICR research in future. During the last couple of months, our team who is involved in organizing this event, they have made wonderful efforts. I appreciate from the core of my heart the efforts made by Dr. Anil Rai of ICAR, Dr. R.S. Singh of DOT, and also Dr. Rabi Narayan Sahu, who was helping them to make this event very successful. I believe your wholehearted participation and also discussions, deliberations will make this event memorable for future. All the arrangements are made here, and for that, a lot of people they involved here. Many committees were there, and they have done excellent work. And all the important points of hospitality they are taking care. Even if there is some lacuna or some deficiency, please let us know. We shall try to make it or rectify it immediately. My best wishes to all of you. And once again, I'm thankful on behalf of ICAR for giving us an opportunity to host this workshop right here in Indian Council of Agricultural Research. Thank you, one and all. Thanks.
So thank you, sir, for those kind words. Now I would like to invite Mr. Ajay Kumar Sahu, who is the Additional Secretary and Member Services Department of the Department of Telecommunications, India, to deliver the keynote. So over to you, sir.
Good morning to all. Mr. Cizo, TSB ITU, Dr. S.K. Chaudhary, DDG ICAR, Ms. Trapti Saxena, Senior DDG TEC, Mr. Sebastian Bose, Chair Focus Group, and officers, delegates present here on remote across the globe. A very good warm morning, afternoon. It's a privilege for Department of Telecommunication India to co-host ITU and FAO workshop on Cultivating Tomorrow, Advancing Digital Agriculture through IoT and AI, and 9th meeting of focus group on Artificial Intelligence and Internet of Things for Digital Agriculture today and tomorrow, jointly by ICR and DOT. DOT plays a very vital role in shaping India's telecommunication landscape through various policy formulation, regulation, planning. DOT oversees the implementation of various government initiatives aimed at bridging the digital divide, promoting broadband penetration, and enhancing the digital connectivity in rural and remote area of India. India's agriculture sector is backbone of our nation, providing livelihood to millions with a vast varied landscape spanning from fertile plains to arid region. India represents both challenges and opportunities in agriculture development. Recognizing the importance of leveraging the technology to address these challenges, the Government of India has embarked on a journey to bridge the digital divide and empower farmers through telecommunications. Through its policy intervention, DOT strive to foster innovation, investments, and technological advancement in the telecommunication sector, thereby driving economic growth and social development. Telecommunication infrastructure form the backbone of digital connectivity, laying the foundation for inclusive growth and development. To realize the vision of Digital India, DOT has taken several initiatives in expanding broadband connectivity and mobile network in remote rural area, enabling farmer to access vital agriculture information and services at their fingertip. The transformative potential of telecommunication in agriculture is amplified by initiatives such as the Kisan Call Center and Krishi Vigyan Kendras. These platforms leverage telecommunication infrastructure to provide farmer with timely advice and support on agriculture practices, pest management, weather forecast, and market trends. Through toll-free helpline and interactive voice response system, farmer can seek guidance from agriculture experts and enhancing their productivity. In addition to providing the access to the information and market information, telecommunication infrastructure plays a crucial role in enabling precious agriculture and smart farming practices. Remote sensing technologies, IoTs, M2M, and drone are enabling farmer to monitor crop health, optimize irrigation, and manage resource efficiently. High-speed internet connectivity is essential for seamless data transmission and analysis, empowering farmer with actionable insight for improved decision making, thus by increasing the productivity. In conclusion, the convergence of telecommunication and agriculture in India is a testament to the transformative power of technology in driving inclusive growth and sustainable development. As we continue on this journey, let us reframe our commitment to the harnessing the potential of telecom to empower farmers, bridge the digital divide, and build a prosperous future for all. Again, I welcome all and wish all success of this workshop. Thank you.
So thank you so much, sir, for those remarks. Now I would like to invite Mr. R.S. Singh on stage, who is the Deputy Director General IoT TEC, for delivering the vote of thanks. So, sir, if you could join us.
Respected dignitaries on the dais and all delegates present here and those participating virtually. On behalf of TEC, DOT, and ICR, it's my privilege to extend the vote of thanks. I extend a very warm and heartfelt vote of thanks to Sri Ajay Kumar Sahu, Member Services, Digital Communication Commission, and Additional Secretary, for sparing his valuable time and gracing the event with his presence. We express our gratitude for your inspiring speech, which enlightened with your thoughts, wisdom, and ideas. The steps and initiatives taken by DOT will certainly serve, facilitate organized and sustainable growth of IoT M2M ecosystem in India. I extend my sincere gratitude to Mr. Shizo Ono-san, Director Telecommunication Standardization Bureau, ITU, for traveling from Geneva to join us for this special event. Sir, we are deeply grateful for your valuable presence here today. TC, DOT, and ICR are truly honored to host this ITU FAO workshop today and the 9th meeting of the focus group on AI and IoT for digital agriculture tomorrow. Your insights have provided valuable guidance that will undoubtedly shape the discussions and outcome of this workshop. Your presence here today signifies your commitment to advancing knowledge, promoting the importance of standardization, fostering collaboration, and addressing the challenges and opportunities facing our global community. I express my gratitude to Srimati Tripti Saxena, Senior DDG and Head of TC, who has been instrumental in guiding us throughout the preparation of the event. Your opening remarks outlined various initiatives and set a positive tone for the proceedings. I extend a hearty vote of thanks to Dr. S.K. Chaudhary, DDG NRM ICR, for truly inspiring and thought-provoking speech. Thank you, sir, for such a profound insights about the various schemes of Government of India and initiatives taken by ICR in agriculture sector for advancing the digital agriculture in India. I extend a heartfelt thanks to Mr. Sebastian Boss, co-chair of the focus group of AI and IoT for digital agriculture, for traveling from Germany to join us for this workshop and to co-chair the focus group meeting tomorrow. I would like to extend thanks to all our international and national delegates for attending the workshop in person as well as virtually. I will take this opportunity to extend my sincere thanks to Ms. Mathli and Kara from TSB Focus Group Secretariat. Last but not the least, I also extend my sincere gratitude to Dr. Anil Rai, Dr. Rabi Sahu, and other scientists of ICR who collaborated with TC in preparing the contributions for this meeting, the technical report, and organizing this event. I would also like, now I would request all the dignitaries on the dais and the delegates present here to please proceed to the exhibition area downstairs for the formal inauguration of the exhibition, which will be followed by high tea there. Thank you, sir.
Hello, everyone. We would like to recommence the workshop of today. If you could settle down, take a seat, we can begin session 1. Okay, welcome once again, everyone. We will now commence with session 1, which is dedicated to cultivating success, navigating the risks and opportunities in digital agriculture. To further guide this session, I would like to invite upon the stage Mr. Shyam Narayan Jha, Deputy Director General, ICAR. Over to you, sir. Please take us through session 1.
Thank you. Good morning to all of you. Thank you, Maithili, for giving the floor. Friends, this is a session is very important. It is highly technical for navigating the risks and opportunity in digital agriculture in actual sense, what we are doing. This session will explore the transformative landscape of digital agriculture by delving into modern farming practices, addressing both the potential risk and promising opportunities. Presented by the integration, emerging technologies such as AI, digital twin, and Internet of Things, and their direct use in the soil practice. These are most of the things are soft, but we'll also discuss something about the hardware which actually being practiced fields. Session will also explore how digital technology can support data-driven decision-making, enable stakeholders to make a strategic decision to improve crop yield, resource utilization, overall farming efficiency, post-harvest loss reductions, and also storage and how it can help the farmer to get more and more income and more life improving strategy how they can apply in the agriculture. This session we have 6 speakers, Mr. Mihir Dakwala, Business Unit Head, and Next Technology. I invite him to come on the dais and take his seat. Mr. Arjun Venkatraman, Program Officer, Bill and Melinda Gates Foundation. You can come on the dais and take your seat. Dr. Nachiket Kotwaliwale, Director, ICR, Shifat, Ludhiana. Please take your seat. Dr. Ravi N. Sahu, Principal Scientist and a Program Leader, actually the driver of this program, whole program. Dr. Sahu, please take your seat. Dr. Anil Rai, the person who is actually creating the potentials between the two forces so that it can flow nicely. ADG, ICT of ICR, Delhi. Professor Krishna Shirohi, Indian Institute of Technology, Delhi, is one of the speakers. Please take your seat. Dr. Ashwini Gajarushi, Engineering Manager, Technology Innovation Hub for IoT and IoE, IIT Bombay. You are requested to please come. And Ruby Pathania, Senior Program Officer of Wadhani AI. Welcome. All the speakers, 6 speakers having varied types, 6 types of experience, soft and hard forms of digital agriculture in India. Also, many of them are having experience of abroad developments. So without wasting more time, I can request the first speaker, Mr. Mihir Akwala, Business Unit, and he can start his talk on the topic assigned to him, and he will briefly provide about the Mr. Unit Head of M&S for Technology. He leads the agriculture vertical AI in innovation, especially analytics. Now the floor is open to you. Give the knowledge and experience to the audience.
Yeah, thank you very much, sir. Good morning, all. It is my pleasure to deliver a lecture on latest technologies with respect to agriculture, which is very close to everyone's heart because entire India's economy is backbone by the agriculture activities. And in the era or in this particular decade, we are currently facing a lot of issues with respect to climate change, food securities, and these are the areas where we need to work in next couple of years to survive our next generation as well as ourselves also. So ITU, FAO, United Nations, and all other government agencies are working tirelessly. I am representing MNX Info Technologies just to provide some brief information about our company. We are started as a startup in 2008, and currently we are in our 16th year of operation. Next, please. Can I use this? Yeah. So we have now currently 8 different verticals where we are using extensively AI, ML, IoTs, and these 8 different verticals. One of the area is agriculture, which currently I am leading. And we have a team of around 150 people in agriculture domain, complying of various multidisciplinary team, you can say, software, remote sensing, data science. Yeah. So these are the fundamental cutting edge solution. If you want to do any machine learning operation or AI ML operation, just I'm going through slightly basic to cover the depth of the project, because the agriculture as well as the use of technology in agriculture is again very much complex. And since everyone has a 4 or 5 month season, if I talk about India, 4 or 5 month season, when we have to do all our solutions, implement everything within 3 to 4 months, right? So ultimately, farmer will get the benefits in terms of yield as well as the prices. So these are the various data source we already have, right? We are also generating data source. So like human farms, land, we have water vehicle. With respect to agriculture, farms are generating data at every second, right? At every day, we are getting different activities with respect to farms through crop life cycle. The next step is we have the data, but how to acquire this particular data? So we have IoT sensors. IoT has to play a very critical role here. Then we have satellite data available, like remote sensing technology. With the help of remote sensing, we can provide or we can forecast the crop acreage and crop yield very much well in advance, right, before the season ends. Cameras are there, which we can install in the greenhouse to monitor the progress of farming activities. Various variable social networks, right? Nowadays, these are the data generation source. So we have IoT as well as the geospatial technology here in agriculture domain. Now, once we acquire the data, the main challenge comes how to communicate the data, right, to a software, if I can say in a layman language, how to communicate data from source to certain part of software, right? Either it is backend or front end. So where we have advanced communication technologies are available, and DOT is working, Department of Telecommunication in India is working tirelessly. And now we have certain use cases with respect to 5G and 6G also. 5G, particularly for agriculture, and pilots are also ongoing, and the results are also getting very much encouraging. So 4G, 5G, GSM, then we have some private communication technologies like NB-IoT, LoRaWAN. Once the data available, we have lots of data, right? But it's like a water. So if you do not have a pure water, so same as the pure data, the data is not going to be useful. So we have to process the data, mining the data, use various statistical techniques to generate the meaningful data insights. Also, we have to apply the local agroclimatic related practices into this particular data churning activities. So we are, we will get the maximum benefit. Otherwise, it is data garbage in and garbage out kind of scenarios. So for that, now we have cloud computing technologies, latest computing, quantum computing now people are talking about, right? So large language models as well as the quantum computing, it is going to be a future for next 1 or 2 years. So every 1 year technology changes very rapidly. So precisely 1 or 2 years, we may get some new technologies, new advancement in algorithms. And fortunately, all these algorithms are available in open source domain in very fast manner. So it is up to a company or a government agency and brilliant minds like young college students or researcher to grab the advantage of that particular technology, as the data is not going to be a challenge in our country. So then a data analysis and visualization techniques are there, where we can use various algorithms. We can use the various decision support system here. And then we can generate the various domain specific insights. So for agriculture, trends, patterns, forecasting, price monitoring, price forecasting, health of the particular crop, disease and pest management, all this we can possible. And now a new concept is, already the concept is called the digital twin, where we can simulate the entire farm in our laboratory, and then we can predict the pest and disease related, or we can analyze whether any change in temperature or any parameter, what is going to be the effect on yield of that particular crops, right? So these are the various sectors which is going to be impacted, right? So key business or key potential area where we can use this particular IoT as well as the AI/ML technologies in future, or currently a lot of things are in pipeline. So farming as a market linkages, finance and insurance, precision agriculture, farm inputs like seed, pesticides, fertilizers, farming as a service, because we are facing many challenges like non-equipment available, or maybe the non-laborer, because nowadays in India, many of the younger generations are moved away from agriculture. So we have to focus on labor also. So farming as a service is going to be a good concept, coming up with a good concept, and everyone wants to monitor on their mobile application or through some web portal that how the activities are going on. IoT monitoring platforms, farm management software, next generation logistics, where we can provide the good amount of logistic facility to farmer at their doorstep, so they can easily migrate or they can easily move their crop in case the prices are not available as per his or her wish. He can store the crop or the produce in the nearby cold storage or any storage warehouse. Quality management compliance, where farmer can get the prices based on the quality produced in the farm. Forecasting of yield, soil sensing and analysis, precision agriculture. Digital marketplace, cold chain monitoring, farm ERP, input supply analytics, data aggregator, blockchain, post-harvest management, crop marketing platform, ENAM, agri-market is there. maybe many of the private agencies have their own market. Government of India is also coming up with FPOs, concept of setting up 10,000 FPOs. So they can also take this particular marketing platform related work. Post harvest management, I already discussed. Satellite is going to be a backbone since the 2017 with the facility of this particular Sentinel satellite, as well as the latest open source deep learning algorithms. Many of the startup are totally rely on generating solutions. So imagery analytics is also going to be one of the key potential where we can use IoT as well as the AI/ML. Integrated platform partnership. Again, it's a private and government agencies partnership, and R&D, which is going to be a key area. Like ICAR is currently doing all the activities with respect to various domain with respect to R&D domains. So this is how the crop life cycle monitoring are going on. So fortunately, we are also working with the Ministry of Agriculture to implement one of the flagship project called AgriStack. We are the developer of that particular AgriStack, where we are generating the farmer registry as well as the digital crop survey. And digital crop survey is producing fantastic result in last 1 year as a pilot. So in UP also currently we are getting around 2 crore to 2.5 crore and daily 10 lakh parcel data on from a ground field for each and every parcel with the geotag photograph, right? So these are going to be a huge data source for Government of India and Ministry of Agriculture to apply all this particular IoT as well as the AI/ML technology in future and get the best benefits. Recently, we also developed the golden record kind of scenarios where entire record of that particular farmer is available in a single platform. Also, we are the developer of Krishi DSS, the other DIP, the Digital Public Infrastructure, and we are also currently in the stage of development, the Krishi Decision Support System. So that's our strength to work with government and provide the maximum our support as a private industry to government, not only with respect to R&D as well as with respect to providing services and development. So these are the data sources as we discussed that. There are huge amount of data source like historical crop, satellite images. We have a API data available now, like a cadastral or revenue map data, then package of practice related data, right? Again, a weather data is there. And using this data source as well as the various APIs, we are generating the various advisories to farmer as well as the government and the private ecosystem partner, right? So all these solutions are common, and AI/ML is playing a huge role here to generate all these insights at every 10 to 15 days and provide with an accuracy of 75% to 80%, right? And of course, the model is again trained very much, but the complexity of the project is such that the agriculture practices changes sometimes very much fast. So this particular year, if I have sown the cotton, next year maybe I will go with the groundnut, or because of the unpredictable weather. Now farmers are also busy using multiple crops like vegetable or short duration crops, so they can get the maximum benefits. So all these data we are getting, but we have to upgrade our algorithms. We have to train our algorithms on a very fast manner without using too much cloud infrastructure, right? We have to also do the optimization between the cost of the infrastructure used here. So we have to, the algorithms we have to develop is like they are consuming very less amount of GPUs. They can run simply on our laptop also. So our focus as an industry and to provide these particular algorithms as IP rights to government is always that in future not too much investment is going to be happened on cloud infrastructure also. So these are the futuristic technologies and solutions where this particular workshop is going to address that. Precision agriculture, we all know that precision agriculture is going to play a very huge role in future. AI/ML, blockchain technologies, where we are monitoring from seed. So from farm to fork, we can monitor using the Hyperledger solutions. and through a common QR code. So user or a buyer can get all the information through a QR code, okay, which is the quality for which particular, what is the weather, what was the weather in the particular area during the entire crop life cycle, right? IoT sensors, integration of renewable energies, right? So government of India is also come up with this particular scheme, solar rooftop in every house. So in future, we should have a common solar rooftop, like a solar farm panel, where farmer can install a simple solar panel in his farm in 10 to 5% area, and he will get additional benefit in terms of the additional monetary benefit, right? So that particular is concept is also going to be emerged in future. Advanced satellites, so the satellite technology is again going to be revolutionized. So with respect to AI, now we have in a fourth stage like generative AI, right? Maybe generative AI will be replaced by some other technology or some other technological jargon in next 1 or 2 years, right? So we have to keep advance in this particular area at every day, at every hour, because models are available. Models are also providing some of the bias kind of results. So more or more data source we have to capture again, right? With respect to agriculture, with respect to other domain, sometimes the life is easy for data scientist or AI engineer, but with respect to agriculture, it is going to be a very tough to implement all these technology in an advanced stage on in a rapid manner. Yeah, so this is the vertical farming concept, right? So this is just, we have also published some paper in FAO in past and with Niti Aayog. So thank you very much again for these wonderful opportunities. Any particular questions we can always discuss in break. Thank you very much.
Senior Dakwalaji. And if anyone is having any questions, any clarifications that can be discussed at later stage, listening all the speakers, I request the audience, they may write some questions, confusions or clarifications in mind, and later on we can discuss if time permit. Next speaker is Mr. Arjun Raman, Program Officer, Bill and Melinda Gates Foundation. Request you to take not more than 15-minute time.
Thank you. I'll try and actually keep it less than 15 minutes. So first of all, thanks to the organizers for inviting me to speak. I must confess, I'm not an agricultural scientist. My work at the Bill and Melinda Gates Foundation's India country office is primarily around leveraging digital for large-scale, population-scale programs, usually with support from the government of India. Some of the areas that I tend to work in are gender equality, which is about 80% of my work, and that will reflect in the conversation I'm going to have today as well. I also support our agricultural and financial services teams in some of the solutioning that they do. Some of the discussions that we have with regard to population scale solutioning will be relevant to the conversation about agriculture as well. I'll limit myself to digital agriculture. The foundation's work in agriculture is fairly extensive. We've been working in India for over 20 years. And so there's a fair amount of work that's been done across the agricultural domain. I'll limit myself to the digital part. Three broad areas. We work in Odisha. We've got programs such as Amakrushi and Connect Odisha, which have been done in partnership with the government of Odisha. These are essentially information access and advisory support systems for smallholder farmers. Similarly, in Bihar, we've been working on what we call the Agricultural Info Exchange Program, which is again an advisory exchange. So multiple providers could potentially join an exchange sort of a model, and then smallholder farmers consume that information on the channel of their choice. And then in the UP, we've been doing similar work again, mostly with government scheme access with things like Kisan GPT and Kisan Chat, which gives access to schemes like PM Kisan, or rather information about those schemes. So what I'm doing here is, this is actually the deck that I'm using is an output of an internal ideation exercise that we did around how agricultural advisory might look for a smallholder farmer who happens to be a woman. The character, the user persona we've chosen is a farmer called Suman. So she's a farmer, she's a member of a self-help group, also a farmer. And the product, it's a hypothetical product, it doesn't exist. It's just a name that we're using for the purposes of the conversation. We call it Sanmati AI. Sanmati, as folks who speak Hindi would understand, means common sense or good sense. So what might such a situation, what might such a tool or such a product look like for a woman smallholder farmer on the ground? We tend to do these exercises primarily from the point of view of being able to project a little bit of how it looks in reality. While the technology is very exciting to look at, drones look amazing, it's a very glamorous space to get into. It's also very easy to forget what it might look like in the hands of users. So that's the intent, and happy to engage in conversations or questions around this. So basic walkthrough of how the process might work for somebody like Suman. You identify the sources of information, the typical channel of access. The one we've chosen here for the purposes of the deck is a smartphone, but as you can imagine, smartphone usage among women is somewhat less prominent than with men. So that by itself is a bit of a bias in there. Ideally, what you want to take away from this is we want to use channels like voice and IVR and verbal communication or conversational communication more than one would use text or app-based communication, simply to make sure that we're making these things more inclusive. Just walking through a series of steps that somebody might take. It could be through an IVR, it could be through an app, it could be through multiple different channels, but you're essentially interacting with the same product every time. And the channel that you select is supposed to make sure that it becomes easy for you to consume and access. Ideally, you want to include local groups to provide that additional context, while devices and IoT and AI will give you a certain picture of things. You definitely want to make sure that you're including local expertise and local groups to augment that and make it trustworthy for the end user. I'll actually quickly walk through to the end so that we can have some time for a conversation. This is what I wanted you to see. So advice should ideally come from multiple data sets. Usually we end up with most products, including the ones I'm seeing here. Typically the option is of only getting information from a single channel or from a few different channels. As we expand the scope of this domain altogether, to encourage more participation, more diversity in the kinds of players that get in there, we want to ensure that everybody has an option of being able to put some standardized information onto an exchange-like platform where there is some diversity available for the user to choose from. This is similar to the models that ONDC brings to e-commerce or Honest brings to education. Very much the network model that India follows, which is enabled by our digital public infrastructure. It should also be accessible through things like a feature phone, through channels like IVR, while smartphone penetration will continue to grow. Making sure that the channel of access is not the limiting factor is increasingly important. Conversational interfaces, to the best of our knowledge, work really well for most communities on the ground. You always want to include some element of a human in the loop, particularly when it comes to AI. This is something we realized is essential even to build trust in the system. An entirely automated system can be somewhat alienating and disenfranchising for end users, which results in then limited adoption and limited utility. Repeat. Okay. So I'll leave this slide up here. Couple of points that I wanted to make when we come and talk about things like risks and challenges. I think one big risk that we see with all heavily device-oriented or technology-oriented solutions is that they tend to displace the control from the community towards a service provider of some kind. So what would be really encouraging to see is more examples where the devices, the infrastructure that actually enables digital agriculture get a little bit, the ownership of those gets a little bit closer to the ground. So examples could be SHG members owning and operating drones, local cluster level federations owning and operating IoT networks or Wi-Fi networks that enable that data to get collected from their fields and then get used by the local community. And there are good models for many of these things. And the goal would be to be able to, again, then connect these back to a central exchange kind of a model where you can then have some back and forth. And then the other advantage of this is that you get very close to the ground real-time data from places where it really matters. Another addition that I'd like to add to this, which might seem a little bit counterintuitive, is the role of women and the participation of women. Esther Bosserup has a nice hypothesis in a 70s book about the plow and how the immense upper body strength needed to operate plows is what sort of got the gender divide in most societies started. Will be very important to keep in mind as we go forward that digital technologies like IoT and AI are actually very labor agnostic. And so it will be very, very important to ensure that we include women in the design and implementation of some of these programs. Great book to read on this is Invisible Women. It talks about how a lot of the products, even something like a cell phone, a standard cell phone is very often designed to be too big for the hand of an average female user. So we have these kind of problems that are inbuilt into our technology design and thinking. And so as we get into the domain of automation, AI, and better decision making, useful to make sure that we bring that lens back to inclusion. That's one of the other reasons we call it Sanmati. And I can pause my conversation here and leave it open for questions or discussion.
Thank you very much. Mr. Arjun has presented mostly on the SLG named Sanmat. Sammat, I think means for the foreign delegates, let prevail good sense. Everyone should have the good sense, utilize the AI and other latest technology very carefully and believing. We see in digital technology always something output comes, but how accurate it is, hardly anyone is thinking about. And I also suggest the Arjun to use the best picture. I see instead of that taking a lady, some heads, that may be prevailing very, very minimal numbers. But we have thousands and lakhs of drone Didi also. That will give the latest development in India. So thank you very much. Now, friends, we have a third speaker, Dr. Nachiket Kotwali Wale. He is basically agricultural engineer, and he is a director, Central Institute of Post-Harvest Engineering and Technology, Ludhiana, Punjab, and also director in charge of another institute, that is National Research Center for Makhana in Darbhanga, Bihar. He is among the first, or maybe the only first person who did PhD in image analysis in agricultural produce in India. His PhD is from Oklahoma State University, and first time we started working on image analysis maybe around 20 years back in India. And a lot of work he has done. He has 5 software copyrights, of course, most of them in image analysis and AI fields, and 2-3 patents granted. And he has worked on not only the software parts of AI and other apps development, but also on the practical use of that. So over to Dr. Nachiket, to you. Floor is yours. Not more than 15 minutes.
Okay. Thank you very much, Dr. Jha, for a very generous introduction. Good morning to all of you, all the audience. And as Dr. Jha said, and as the picture, the first slide that depicts here, that I am not going to talk only about digital technology in the software domain, but going slightly beyond, even talking of some of the hardware applications and appropriating these things for the Indian context. Some of the research slides that I would be showing, or developmental slides that I would be showing, are taken from the research of our National Agriculture Research and Education System, that comprises of ICR institutes, state agriculture universities, central agriculture universities. So some of those things would be taken from that. To set the context, let us see that the advancement in Indian agriculture has been tremendous. The market size of IT industry is increasing. Development of agriculture system has been over the years. Mechanization is in increasing trend. Digitization, especially for precision and also for mobile applications, huge number of them are there. I am thankful to my previous speakers who have set the tone and who have introduced these things to you in the beginning itself. On the other hand, if I want to justify that why mechanization, why automation is required, we can see that the share of GDP, agriculture in the GDP has been reducing. Means it's not that agriculture is no more important, but it is that more people would be migrating. If you see the other part, employment part, that is also reducing. So it shows that more people are getting employment in the other areas and the people available for the agriculture would be less. Comparison of cultivators and agriculture laborers is again you can see that it is reducing, although there is a slightly increasing part in case of the hired laborers or unskilled laborers. So it is showing that if we want to move towards somewhere on the advancement of agriculture, to continue the pace of agriculture, to continue our growth, then in that case, mechanization vis-a-vis automation, both are imperative for us. All right. These are some of the agriculture unit operations. I'm skipping through very quickly through my slides because probably number of slides are little too much for 15 minutes. So different operations that we can see is like land preparation, seeding, planting, crop care, irrigation, fertigation, harvesting, post-harvest operation, transportation, and then marketing. So all these areas are there where we see there is a huge scope of digital agriculture or digitization for the sake of attaining precision, for the sake of reducing the losses, for the sake of maximizing the profits, and for the sake of timeliness of the operations. And these are some of the emerging technologies using artificial intelligence, using Internet of Things, big data, robotics, everything that this workshop is going to cover includes cobots and drone technology and then also on the blockchain. So variety of applications, I would be in my next few slides, I would be showing you variety of applications that have been developed or that are under development and use of many of these technologies. And along with that, we are also using all the 6 senses present in the human being in an artificial domain, all the sensors which are replacing those 6 senses that also are being used and training taking those sensors as our data generators and then training them to take an appropriate decision. Because ultimately talking decision making is the key feature in everything in agriculture. In agriculture, why only agriculture, in any wake of life, taking a decision is the most important thing that happens. There are these 6 technologies: robots, drones, remote sensors, computer imaging, machine learning, and analytical tools. All are there, are mixed. All of them are complementing to each other. And then we are going into cultivation phase where seed selection, land preparation, water irrigation, and seed sowing, all these things we are taking care of. After that comes the monitoring phase. Actually, the previously shown unit operations of agriculture, I have just listed them in different 4 groups. So one is monitoring, where we monitor and take decision where the crop is being grown at that time. After that, the harvesting stage comes, different unit operations depending on the crops are there, and then post-harvest phase, which is equally important. And to your information, the post-harvest losses, which can be curbed using an appropriate decision making, are huge in this country and everywhere. Then again, coming to different type of technologies which are available, digital technologies which are available and their applications.
which have been attempted or which have potential. So these are some of them, which like the 6 technologies I talked earlier. Among them, these are some of the things. Mobile applications, already my previous speakers, they talked about them. Drone and satellite imaging, I believe my next speaker, Dr. Sahu, will talk about it. I will be mostly talking about the IoT sensor application and some robotics, and then use of biochain blockchains also. So again, the same thing. A similar thing. I'm presenting in a different way, that we are first getting some kind of data using some appropriate sensors. There, I again tell you that all the 6 senses, be it vision, odor, sound, position, biochemical, or touch. So all the 6 types of sensors are being used in appropriate coordination, and whatever results are coming, though, whatever the data is generated, that is getting evaluated. That is, we have to plan how to use these sensors in appropriate coordination. An application is being developed, so different applications you can see from outside, and then ultimately it leads to some kind of results or some kind of actuation. Among the robotics application, grafting, transportation, weeding, spraying, planting, irrigation, picking, harvesting of crops, post-harvest quality and food safety management, and storage or inventory management. These are some of the applications on which already some work has been initiated. There are autonomous robotic systems. We tend to, we are in a way to develop them. So this is how they probably work. There is a main task, and then these tasks are broken down in different tasks. That human robot interaction could be there, supporting task. Other than that, object identification, object detection, then identification of the problem, and then taking an appropriate decision. These are some of the applications that I would like to show to you. They are, of course, on the prototype stage, and they are not at a finished stage, I would say. But just to show you that we have already begun these things. And as my topic is appropriating these technologies for Indian context. So just to show that this is a weed detecting robot. This is another one, which is a planter, developed here itself in Delhi, in one of the ICR institutes, which is for planting different seeds at a no given row spacing and plant spacing. Another is cotton harvesting. A private NGO, they have started working on this, wherein a cotton picker has been developed, which goes in the field and picks the cotton, which is one of the most tedious jobs. Transplanting is another area. We already have started developing the transplanters, as well as rice pellet seeders. So these are our applications that are under work. Then last season we developed a apple picker using not only the robotic arms, but also giving it a complete brain behind it is artificial intelligence. How to identify a apple on a tree, how to perceive the depth of that tree, how to find out whether the apple is ripe or not, and then guide the arm to pick this particular apple. Then next stage comes is robot in warehouse management. Although in the agricultural warehousing, so far this concept has not been implemented. This is an application or example shown from the Amazon. And in their warehouse management, they have started using robots for picking appropriate item from the shelves at different. We find that in a very near future, we also would be able to automate our warehouses, grain warehouses, or cold storages using these type of robots. Irrigation, as my colleague will also probably talk about it. And we have different types of irrigation, like it could be drip irrigation, it could be flood irrigation. And we have developed not only sensor-based devices, but whatever data is coming, based on that, we have artificial intelligence-based solutions to monitor the irrigation of this type, or to monitor the irrigation in the drip as well as sprinkler as well as flood irrigation. Coming to fertigations, we have systems which are kind of a cobots, not completely robot, I should say. Human are there to help in not only traversing the system but also taking certain decisions on the field, whereas it is assisted with some kind of sensor-based devices. Plant disease diagnostics using cameras, infrared cameras, and then whatever images are coming based on that, some decision is to be taken. So those decision-making trees and those decision-making algorithms are ready with us. Real-time uniform spraying, this is also another application where when the tank of a sprayer gets emptied, the uniformity of spraying rate reduces. And we have developed a AI-based solution in which it observes that how much is the requirement, and based on that, uniformly the spraying rate is maintained throughout the field. Other areas which are being explored or which need some kind of attention is seed quality detection. To some extent, we have done that, but it needs additional on-field pest management. Again, as I showed, disease detection has been done, but that this also needs then on-the-go soil sampling and soil quality detectors. At present, the soil quality issues, those are hampered because of the time that is required, and we hope that this will definitely help. Picking and harvesting of commercial crops, huge number of crops are there. Then there are varieties within a crop, so that poses a big challenge for us, and a machine developed for one particular variety may not work for other variety. That is one of the risk. And then scouting for crop insurance is another area. Coming to a little bit very quickly, I will go through post-harvest operations also. The major issues in post-harvest are the losses. Another is wide variety. Huge number of crops are there. Huge number of varieties are there within the crops. And then efficiency of the whole system. These are the three things which need to be addressed, along with the quality and safety of the crop. These are different unit operations at which we perceive that different type of algorithms and different type of machines are required. I will talk one by one. These are some applications that we have developed, sensor-based applications for detection of quality. There is no actuation, but quality detection and alarm generation. Then these are some odor-based or gas-based sensors, artificial nose, you can say. This is what we are working on. Then coming to AI-enabled machine vision system for grain analyzer. You might have seen in the ground floor that there were some applications shown. And we also are working on that how grain quality can be ascertained in a very quickly and in very reliable manner, and robustness of the software is very much required. Other than that, for ensuring safety and quality of product, we are also into hyperspectral imaging for safety and quality of different types of products. This is radiography, another area that is now picking up in India, especially for some high value fruits, is radiography, and conglomeration of vision as well as radiography. We are already working. And here also, a huge set of information is getting generated in form of images, and then we are developing appropriate AI algorithm, which are resulting into development of these type of systems, which are vision-based systems. This is also another vision-based system in which we are grading and sorting of fruits. Along with us, there are huge number of startups also who have come out with some kind of machines for AI-based or some IoT-based devices, which can be used for grading and sorting and quality detection of different machines. Automation of supply chain and traceability is another issue that we are addressing. In this, quality detection at warehouse, inventory management, and logistics. All the three are being controlled and monitored. And this is how a transportation vehicle might look like, which is completely enabled with IoT devices and monitoring different things and taking a decision based on the quality of the product as well as market demand, and at the same time looking at the weather conditions, traffic conditions, and so many different type of devices. So a blockchain technology we are trying to develop to control the control the, I won't say control, or rather monitor the environment, microenvironment inside a storage, inside a transportation truck for banana, and then guiding that truck to an appropriate market based on demand as well as based on the quality of the product. Then radio frequency identification, this goes along the way in the whole chain. As I told that take use of AI or IoT is just, these are some of the algorithms or softwares, but you need to have data. So RFID becomes a very handy kind of device, which we have been using for monitoring the microenvironment as well as the quality of product, and then transmitting it over the net for taking an appropriate decision. These are some of our sensors that we have developed. Along with that, the challenges that we talk of digital agriculture is one is the limited awareness. That could be one challenge. Another is affordability and access. Of course, with time, it is coming. Affordability is becoming more. Connectivity issues in some areas, some remote areas, there might be some issues related to connectivity. Language and literature barriers are there, but as my previous speaker said, that there are people who are working on that different communication is not hampered without language. Complexity of technology, that needs a very trained manpower, and that is also one challenge. Traditional mindsets and resistance to change. Many of the farmers, many of the end users and stakeholders, they are not ready to change just because they don't trust these type of technologies, and there are huge reporting of frauds and other things also in this area. And because of building of trust is also one challenge. Fragmented agricultural landscape, it changes from place to place, different crops, different varieties, shortage of local support and limited government support and infrastructure. These are challenges which definitely we are looking at solutions for that, and this workshop is one of that. Required to be done, we need to have ample data. Any artificial intelligence solution, it depends on the data and fidelity of data. So if appropriate data is not there and it's not correct, then definitely it will lead to some kind of wrong decisions and logic development based on that. Then comparable and compatible hardware, and of course robustness of the hardware, that is also another challenge. Many of the solutions we see are coming which are ephemeral, which are very short lived. The solution works maybe probably only for a very short time of period. So that type of solutions are probably good to look at but not good to work with. And for all these things we need some kind of HRD, complete HRD plan in case of AI, IoT, hardware, and all the domains. Thank you very much. I acknowledge three people for contributing in this.
Thank you, Dr. Nachiket, for giving the holistic picture of AI, IoT, and sensor technology, and of course robotics, full agriculture. What I see personally, that most of the work is 90% or more than that is devoted to production side of agriculture, post-harvest, handling, transportation, quality, foods all are left. So complete holistic picture you have given. One thing I should tell to the audience that India is now in position of deploying a stage of IoT and AI, at least in the micro irrigation systems. We have so many farms, good amount of area covered without any human beings, autonomous area for irrigation systems. We have advanced a lot and much better than many other countries. And also robotics we have started, as you have told. So later on we'll discuss more when time permits. Now we have speakers, relay speakers, you can say, relay speakers, 3 speakers together. Dr. Ravi N. Sahu. Ravi N. Sahu is actually the driver of this program. Not only this program, but he is also the program leader of ICR network program on precision agriculture. He is principal scientist and he is a very good physicist in agriculture field in IAR, Indian Agriculture Research Institute, one of the premier institute of agriculture in not only in India but also in the world. His major research is remote sensing, application in agriculture, hyperspectral remote sensing, soil and crop health monitoring, drone remote sensing, precision farming, plant phenomics using sensor at ground, air and satellite platforms. Means all the 3 stages. Underground you should have also written, otherwise 3 phase will be there. Second speaker will be in this group is Dr. Anil Rai. You may be knowing him. He is the Assistant Director General ICT of ICR, Indian Council of Agriculture Research. He has worked for more than 45 research projects and coordinated 3 major national network programs related to AI, digital agriculture, and more than 300 research papers. And third speaker is from IIT Delhi. He is the Professor Krishna Shirohi, Indian Institute of Technology. He is a professor of practice. French government of India has introduced very recently, professor of practice. And he is one of them. It will be very interesting to listen that how the practice, whatever you think that is put into the practice. So I welcome all the 3 together and starting with Dr. Sahu. Floor is yours now.
Thank you, sir. And very good noon to all of you. Welcoming all delegations from abroad and also India. And very good evening and good morning to many of who are virtually have joined across the border. So I'm going to deliberate on embracing new age technologies for precision agriculture, challenges and opportunities. I have my co-authors with me, Dr. Anil Rai and Professor Krishna Siroy. So much has been talked before all the speakers, so I don't need to talk much on that. What are the challenges? What are the issues related to Indian system? But when you talk of precision agriculture, it's nothing but the smart way of looking at the farm, how best we can see the cutting edge technology is implemented in the farm. So for that purpose, the major focus remains is how to optimize the yield, not the maximizing the yield. And optimizing the yield can be done managing those variabilities. And the variabilities may be in both spatial, temporal scale, how we do those variabilities with respect to soil, with respect to the crop, and also the climate change or weather variations, using all these technologies like sensors, AI, and data analytics. And the purpose is, again, to make it profitable to the stakeholder, that's the farming community, to make it profitable, sustainable, and also environmentally safe over the years for the next generation. And the list of technologies over you see here is the challenge remains is how best we can embrace all those technologies to make it real time and make it possible the conditions like Indian ecosystem, where you have a small marginal farm holdings. And again, how this is again opportunity to look at, that's the reason why Professor Siro is here to look for the communication innovation service science, how best we can use that. And you know how mobile network is spreading over all through the crowd and how easily we can reach through the mobile network system and how best we can use 2G, 3G, 4G, 5G, future 6G program for that purpose. So coming back to the intelligent sensing is nothing but the data analytics, AI integrated with the sensors, how best we can use that to make an intelligent sensing of the crop health, both for the biotic and abiotic stresses, monitoring crop growth on the spatio-temporal scale, optimizing the yield and also damage assessment, make it more of real time. And the main challenge is how to design a new crop, how to design a new plant type using some of these tools and techniques, integrating with the multidisciplinary team like plant sciences, genomics, genetic engineers to make it a smart crop which will be more resilient to the climate change, less input requirement, and more production system. Again, using all those smart tools, whatever available with us. So coming back to the sensors, so we have been working quite some time, starting from the lab conditions to the satellite level, how best we can use all those signals what we receive from the target, maybe the soil, maybe crop, maybe water, to characterize that and to see how best that can be used to make it a farm practice and make it more of a real-time scenario. So you can see across how the scale is. When you are in the ground, you are with a single pixel level. When you are at the satellite, you are looking at whole ecosystem level. So those are the prototypes what over the years we have been developing. Again, over the years, the sensor technology advancement has been taken with respect to spectral resolutions. You had a black and white picture. Now you have a hyperspectral camera having 1,000 channels with you. You have a radiometric resolutions having only 2-bit to now 16-bit resolution. So little change in the signal. You can be able to see what the stress is in the plant itself with the water or the temperature or the nitrogen stress. Also, same time, you are able to see the pixel resolutions starting from 8 kilometer down to now 20 centimeter, the satellite level what we have. Of course, the drone technology has also addressed some of those solutions to look at the marginal farm holdings. So this is what I'm agreeing. Again, you come back to the repeativity. We have a 24 days to 30 days repeativity. Now it has come down to 30 minutes. Even drone technology is going to take you as and when you require for that purpose. So this is what the scale of operations, what you have. Over the evolutions of the agriculture sciences, what happened over the country, you see green revolutions, 1960s and 70s. Now it is a green revolutions, what we are trying to do. We are redesigning the crop using the plant phenomics facility. Today afternoon, I think we have a field visit to see what are those technology, what are the sensors there to see both field phenotyping and also Nanaji Deshmukh Plant Phenomics Center. And we had 1969, we had the first thermal camera flying over there, the coconut wilt disease could detect. And now we have a hyperspectral camera flying in the field, trying to discern composite stresses in the field and also stress levels to address some of those problems what we had over the years. So this is what the advance over the years happening. This is what the infrastructure, the facilities, the technology which has come up is very easy to access now. Coming back to simply a single channel of thermal camera to hyperspectral having 1,000 channels what we have. You have a satellite, you have a ground drones starting from a 10,000 a drone cost to 4 lakh or 50 lakhs drones, which can fly at any time. And you have also same time, the all in-house developed the pipelines, AI-based methodology, which can be implemented in the real-time basis. And coming back to the high throughput phenotype, standing on the limited conditions like climate control conditions, where environment is taken care in the facility itself, you can have all the decorated sensors you have, and in real time, you're able to capture those data. Same time, we have in the field the framework where the image is captured and also on the drone to see how genotype and environment interacts and express and how phenotype is changing and how you can redesign the crop using those data analytics. So this is particularly for the purpose of new variety development and also to understand the traits, the characters of the plant and the soil to go for the precision technologies. Coming back to the data analytics, AI, I think a lot has been talked about that. We have been doing when you were a student simply empirical modeling equations. Now we are talking of deep learning, AI, and many things, regenerative AI, what we are talking of. Of course, we have also physical process based on understanding how the radiation signal comes from the soil or plant, go to the sensor, interacts, and you can simulate the signal without flying the sensor. At the same time, also revert, you can get the parameter down. So this is what over the years, the technology has gone, and this is what the capacity over the years we have built up. Some of those applications to look at the soil health to see how AI technique can be used, machine learning program can be used, and whatever the satellites are up on the sky, how we can use those, pulling them together, developing a new concept called digital soil mapping. This has been done in collaboration with my colleague from NBS LOP, Dr. Nimble and team. And you can see the coastal district of Odisha, 7 district, you are able to see soil organic carbon map in 10-meter resolutions, the European Space Agency data, what you could do. And you have a 6 lakh samples, which is collected through conventional approach of soil health card that can be reduced to 3,000 soil samples using this machine learning based approaches for the sampling strategy. So this is what the technology which leverages and which minimizes the cost, what you want to have and make it a real time to look for. And this is what you can see whole integrated plane, how the soil parameter has been captured and also cropping system has been captured using spatiotemporal data, which is available on the time series satellite data. And same time, you are able to create a homogeneous unit. All those colors you are seeing nothing but the 24 homogeneous color units. My colleague, Dr. Das is here, Ansel Das. So we have worked for that to find out how we can bring the precision in the pan Gangetic plains with respect to customizing the fertilizer doses where you can apply for. This is nothing but the precision agriculture you can bring big way. Coming back to the real solutions, all the information what you get from satellite, how you can capture, put into a small mobile. That's what the story tells about here. This is somewhere in the Dhamantiri district of the in the Madhya Pradesh, where we could do digital soil mapping. Farmer goes with his mobile, he have a geo coordination, he's able to know the soil health, and he's able to know last 10 years what is the yield trained. That analysis has been done, put on the server, and mobile gets into the server, and you are able to get what is the target yield, what is the inherent soil fertility status. He's able to get what the fertilizer dose he should apply to get that yield. And this is what the app has been developed, again, in collaboration with Indian Soil Science. My colleague, and Dr. Nishant is here. I think this is what some of those success stories what we have. Coming back to the monitoring of the stresses in the case of plant, this is what the sensors you have. This is what the signal you try to get from starting from 400 to 2500. Also beyond that, the kind of sensors capability what we have, and how you can capture, find out the spectral specific ranges to nitrogen stress or water stress or the pest or disease, and discern them and go for the real-time solutions. Looking at some of the examples of AI, simply using RGB camera flying on the drone on the maize crop, you are able to capture the tassels using some of those CNN models called ELO technique. You look once. So this is what you are able to do, which has reduces the cost of labor, cost of the time, and the effort what you need to. So this is what the technology leveraging to the farming community. And look at this. This is what the camera flown over a field where you have a spatially variable canopy temperature, which tells you which field has a water stress, which doesn't have. You have a solenoid valve down there, drip irrigations can be actuated, and the irrigation can be done, or you can go site-specific irrigation for that purpose. Looking at this, once you fly a drone or you have an image of high resolutions, you can run those AI-based processes model to generate a biophysical product like leaf area index, chlorophyll content, or nitrogen content. You don't need to understand what the sensor works or how the drone is flying. Simply a biophysical product can be generated and which can be used, even if also prediction of the grain yield before harvest you are able to do. So this is what the biophysical product you are able to generate and go for the applications for the site-specific applications. Going to the next, this is what the low-cost technology is, what simply based on the RGB camera, how you can go for the nutrient fertilizer applications. This is what, again, colleague from NRRI and team from IRA, they have been working. Team from Wheat Research Institute also, they are working. Coming back to the pest and disease, starting from a high-end sensors to find out what are the spectral ranges for pest and disease. We are also able to do from airborne campaign with JPL NASA to find out yellow rust disease in northwest part of the country. This tells you how to make it a real time and finding out the predictions of the quantity or the scoring of those diseases, finding out the ETL level, then you can go for the management options. This is what, again, AI taking unit architecture, which has been done for the RGB image to find out rice blast in case of rice. This is, again, AI-based technique for early predictions, looking at the pattern, the way it is. Again, same thing we are trying to implement on the drone to find out some of those pests and diseases in case of wheat, aphid, brown plant hopper in case of rice, and also many other studies we are able to do that. So to make it a more of a real-time story. Coming back to, so this is what I'm talking of the airborne. Coming back to the satellite level, this is what the real-time data availability, real-time monitoring systems. This is what the pipeline has been developed. Anybody can just go or digitize a area, whatever area you are looking for, automatically will capture all the central series data and get you a color map like this, which field is really working good, which is bad. So this is what right-hand side you are able to see. We have 100+ villages all around NCR regions. We are doing real-time monitoring using Google Earth-based engines, pipelines, and the satellite-based real-time monitoring system. So this is what the smart farm, today afternoon, 4:30, we are all making a plan to visit this place. So this is what the field where you are, and you are able to fly the drone, you are capturing the data, all those possible informations you have. You have a digital soil map which has been generated, and you are able to actuate the drone, which can go and feel and spray, where to spray pesticide, where to spray nano fertilizer, or all those things. So this is what the kind of a case studies or SOPs we are trying to develop and trying to implement in the large scale. IoT much has been talked by previous speaker. I don't need to talk much about, but again, under this program, we have developed some low-cost IoT-based sensors for making an intelligent irrigation system in different parts of the country, including banana, including tomatoes, rice, and wheat, and many other places. So this is, again, what the story with the Agriculture Engineering Institute in Bhopal. This is what you were able to see in case of maize crop, and also automating flooding in the basin scale is there. So this is what I would like to speak about. And next is Dr. Anil Rai. Sir, please.
Good afternoon, everyone, and thank you, Dr. Ravi. He has already covered many areas of AI and IoT. And this slide, as you see, that there are so many communication devices and there are so many types of sensors. So the present problem is how to integrate all together and complete the whole process of agriculture, basically from planning, production, and post-production. So because as a farmer, he needs a complete solution to his field or to his farm. So this is the one area where now we are trying to focus in the Ministry of Agriculture, and I am coordinating with different departments and including DOT also. I am coordinating with them to find this kind of solution, and that needs a complete solution and integration of all the platforms, whatever devices you have and whatever format you have. So this is what area we are going to cover. And that should have a agriculture intelligence system. That's what we conceive overall. And in this line, as in the morning session inauguration, my DDG, NRM, he already told about the IDEA platform, that India Digital Ecosystem for Agriculture. So that framework we have already there from the Ministry of IT. And we are trying to build the whole system. And that system will sustain only, we have a business model for the same. So for doing the business model, we are trying to work with the startups and entrepreneurs working in this area. And then, everybody has to be benefited from this whole system. And like farmers, they have some benefit like reduction of cost of production, better value of their produce, and risk coverage. Their risk coverage is highly risky crop, agriculture, and competitive financial support. So all has to be integrated in ICT platform from business. Complete value chain of agriculture has to be integrated into this, including industry, government, and R&D institutions. So this slide shows that particular format. And that though there are a lot of challenges also, and for doing this, like in India especially, we have a small farm sizes and then limited access to the resources. This is a challenges, especially for the developing countries, underdeveloped countries, and poor infrastructure, low use farm technologies, and best farming practices we have to implement. Though that we have to invest into the agriculture, and a lot of post-harvest losses. So these are some challenges, but apart from the challenges, if you talk about particularly in India, we have a lot of opportunities also. Like our digital infrastructure is very strong in the country, and we are ready to adopt all these technologies, and we are ready to reduce the cost of implementation of the technology. And in this area, especially we are in the ministry, we are developing a agri-stack. Agri-stack means we are trying to standardize the all kind of system and ecosystems of agriculture related to agriculture, and developing the registry, keeping we are encouraged by our DPI related to Unified Payment Gateway. So gateway interface. That in India, that is leading the world in this area. And there's a 59% increase in volume, as well as 49% increase in value of the transactions, financial transactions through these gateways. So what I want to emphasize is that we have a mobile network penetration, mobile and the digital penetration is up to rural area. It is around 48% in the rural sector. So we have a lot of penetration, and we are ready for that. And that's why we are trying to develop this digital public infrastructure, common standards for integration of different devices and different communication systems, so that we can provide a one-stop solution to the farmers. And these are some of the initiatives what we have taken in the country. And ENAM already, my DDG already mentioned, and the DBT is there. Aadhaar is one of the unique example for the India Digital Agriculture Mission we have already talked about. And, but some policy changes are also happening, and that's required for supporting this. And like public-private partnership, I have already told about. then digital empowerment of the common people, and demonstration, capacity building. So in all areas, we are working on that. And there's one program we have initiated from ICR, that is Kisan Sarthi, means the navigation system for the farmers from the planning to the post-harvest. So everything we are trying to navigate, and we have connected farmers directly to our experts in different areas through this digital platform that is called Kisan Sarthi, and where around 17.9 million farmers are already connected, and we have covered around 35% villages in the country. So we are pushing the technology, we are connecting the farmer, we are providing the solution to the farmers to the platform. So now, fortunately, we got a 5G lab also, and IRI is one of the labs where we are going to visit. So now I invite my colleague. He's talked about how we are going to be more productive in this area through this 5G innovation. Thank you.
Yeah, namaskar. I'm professor at a communication institute, part of Indian Institute of Technology, and my specialization is how cellular technology can be utilized for developing a sustainable solutions in various verticals of the business, and agriculture happens to be most critical, business segment for us. And what I look from the perspective little different than what has been talked about so far is what technology can bring, what all can be achieved. Lot many prototypes and the pilots have been mentioned. I want to look from the angle, what is the problem which is not being solved in a very sustainable way, and whether the today's technology is adequate to solve that problem completely, or we need to enhance even the technology. And that's the case I'm talking about, that 5G as a communication technology gave a promise to the world that if you put 5G as a private network for industry, then you can really solve a lot of the problems which this manufacturing and industrial automation sector is facing. And now, if when this technology came to the reality, then people identified that the 5G of 2020 was actually not enough for making those industry 4.0 implementations. And so the advancement in the technology was necessary. So 5G of 2022, 5G of 2023 became the necessary part to solve industry 4.0. And now what was missing and what is actually added in last 2-3 years in 3GPP standardizations is basically a capability of real-time communications, low latency, very high reliability of the wireless communication, which is necessary to digitize any critical operations. And with this is going to be a practical phenomena of setting up a private network of 5G for realizing various applications. And we are looking from this perspective that when the 5G is being put up as a private network to solve different problems, then what more need to be done from the technology enhancement perspective? Now we have seen that what user is looking for solutions, the use cases, and we are very much familiar that these use cases are implemented by huge application of artificial intelligence. Now, artificial intelligence is not limited to be hosted at the cloud. Artificial intelligence must be in the box. When the artificial intelligence must be in the box, it could be at the network edge to be much more efficient to make digitization of your real processes, which needs a critical real-time intervention for monitoring and also control, like any robotic control systems. This you will require this artificial intelligence algorithm must be distributed. Something should remain at the network edge and the rest should go to the device edge. Now, if you need this kind of distributed AI in the box, then you need a very critical communication infrastructure underneath. And that is what this 5G advanced communication technology provides. So we look from that angle as a Bharati School of Telecommunication at IIT Delhi, that what all the use cases we can actually develop so that it becomes globally competitive, it becomes ahead of state of art. And that's what our goal is. So we associate multiple startups with us who take this technology for productization. And this is one example that one of the IIT Delhi startup is now setting up 25 5G private network in academic institutions, and one of them happens to be IARI. So this, we are driven by the kind of the business growth which is going to happen in this case. And I will not read these numbers, but these are important, driver for us for the research. Now, another important part is, as I mentioned, that these solutions to remain really competitive and also solve the problems which still remain unsolved today, then these technological solutions must graduate from the current technology class, which I would say the advanced 5G technology class, to a pre-6G technology class and also a 6G technology class over the just 8 to 10 years from now. So if we are attempting to develop those sustainable solutions indigenously, we need to have a complete design control on these aspects. And these we want to do it in a very collaboration with multidisciplinary research approach. And our collaboration with IARI comes in this context. So we want to work together to develop those communication solutions in such a way that the problems are actually solved in such a manner that these solutions become commercially utilizable and extremely deployable. It is not, we are not happy just by prototypes. You will be able to see a complete 5G network flying in the drone. So there is a use case. But this is a prototype today. Unless until we make it so rugged and useful and applicable from all sustainability aspects, our exercise will not end. So this is our focus. So this is the first picture you see. This is very small network in a box, which is fitted with this drone. And the idea is that in case you are not able to provide all your fields 100% radio coverage, then you can possibly create a mechanism where network can be provided on demand. So imagine a cluster of say 10, 15 villages. There is one network which can fly over these villages and all these fields and get your monitoring information once in a day or maybe faster, right? If this is the scenario, then I'm not dependent on providing the sustainable communication infrastructure by my telecom service providers, because their services ends when the economy also fails. So to create a sustainable solutions, they are happy to provide their best services in the economically viable zones, but my agriculture is there where actually there is no attraction for the business network service providers. So we have to find a method. We have to find a method how the agriculture monitoring and sustenance will become self-sustaining in whatever new business model emerging. So these are some of the solutions which are already we have worked out in our labs and which are potentially being used for many of the future solutions. So the difference here is the drone so far is flying with the sensors, and now it is taking observation from the field. Now in this case, we are flying the network and sensors are on the ground. So this is a very innovative and going to make a significant change. These are the different areas in which we work: agriculture, precision agriculture, and smart productions of agriculture production is one of the part. But we consider ourselves as a central point of the communication which is needed in all these application areas. And when as a target, we want to put up this prototype, most probably at the IARI itself, where we want to do a complete chain from the production, crop management to the soil management to the productions and also managing the entire supply chain. So the technology is in some form already there. It is certainly good for us to realize a prototype system of this maybe in the next 6 months to 1 year, but to optimize it to the extent that it will become really sustainable and cost effective for the deployment. That is something our challenge. We want to address that challenge within 1 to 2 years time of line. Thank you very much.
Thank you, Dr. Sirohi.
If there is a time, I'll just introduce one point.
Very good. I was thinking that in relay race, we do that together, but here in 3 persons, take the 2 persons time. So no problem, even then we are happy that instead of 3 person, we could get the knowledge of 3 instead of 2 people time. You have given a very good idea of 5G, 6G communications and internet and communication between the different. I really appreciate that 5G, 6G should be in the box local network area. If that is done very fast, it will be very, very important for management of not only agriculture, many other activities in the industry also. Smart crops, climate change, remote sensing, all those things have been talked. Sensor development, but has not been talked by anyone. So without losing time, I request Dr. Ashwini. I have told that she has come, yeah. Gajarushi, she is engineering manager, technology innovation hub for IoT and IOE, TIH IoT from IIT Bombay. And she will talk on decoding the ecosystem of agriculture for the next green revolution. I think we are talking for everlasting green revolution. So already we are in the phase of that. So thank you, madam. Now this is your floor. I kindly take not more than 12 minutes.
Sure, I will try to finish early, sir. So first, I would like to thank Professor Krishna and Professor Rabi and Professor Anil for setting up the ground for me. And basically, I will be talking more about being a engineering manager for Electronic System Division of Technology Innovation Hub for IoT and IoE. I would be talking about more on the hardware aspect and how we can solve some of the challenges what Professor has just highlighted with the help of these IoT. So before starting, I would just like to take you all 4 years before in 2020. Exactly this time was a pandemic time and we all were locked because of the corona. Exactly this time, 4 years before, India has been announced the lockdown in the India. Entire world has locked inside the home. But was our life? No. We were like urban life was moving like anything. We can meet, we can learn, we can have means we can have a meeting with a doctor. Everything is going online. Our schools were going online. We were paying online. Banks were online. Everything we can. So, in short, our life has completely become a digital life. We had entire globe, everything in our hand, in a very small laptop or even on our mobile phone. So we completely transformed our life for almost a couple of years on in the digital manner. But is that actual life? Our actual life is agriculture. And the agriculture is what we can say is a lifeline of life. And now that lifeline of life now needs further sustainability, considering the food requirement in 2050, considering the economical growth, because 50% of the population is based on this agriculture, livestock and all. And the threats are severe. Threats are climate change, which is not in our hand, soil degradation, which is again not in our hand, and similar problems. Which, so how we can have this sustainable life? And digital agriculture is one of the option for the sustainability, through all these media. So I will not talk much about this because it has been already into discussion, like precision farming, IoT and sensors, not only for farming, pre-harvest as well as post-harvest levels. Also for drones, robots, flying network, that also we saw just now. Similarly for livestock, aqua farming, everything. And this will all depend upon, or all everything will be based, or the success of this IoT technology will be based on how critically we can predict the upcoming pest, diseases, requirement of soil, need-based advisories. So decision support system and AIML. And if this comes into the picture, how it will benefit us, like with the help of these sensors, we can specifically apply the need-based agri-chemicals, for example, for the soil. We can apply the need-based pesticides based on the upcoming or as per requirement of the crop. So crop specific requirements, soil specific requirement we can take up. So this need-based application of agrochemical definitely will help in the reduction in the cost, decrease environmental impact. So we can go sustainable. Though we have constraint with respect to climate, with respect to soil, we can still go sustainable by reducing these inputs, and also at the same time increasing productivity, and thereby matching the objective of economic growth and food sustainability. But is this implementation so simple the way we are talking here? And this implementation, the success of this implementation would be, of course, success of any technology is based on the customer satisfaction. And our customer is a farmer here, and adaptable and accessible technology development is a crucial in terms of farmer. And if we see, there are a list of problems with respect to technological, societal, economical, organizational, which need to be solved before a large scale implementation of this technology worldwide, or even a countrywide, or even a statewide. And technological problem I will talk shortly, but if we see the social problem, definitely we can give the training to the farmers with respect to the building the skill sets. But what is their adoption would be based on the cost of the system, robustness of the system, how it is friendly for them to build that system in their farms, and security of the system. Not only data security, security of the hardware or IoT systems or the drone, reliability of those systems, reliability of sensors. So when we list all these problems, though they seems to be social or economical or organizational, they all funnel down to the technological problem, and wherein we need to solve the interoperability, cost, network access, scalability, energy efficiency, data security, as well as a hardware security for the sustainable technology based on the sustainable digital agriculture technology. And so let us take a see here what is exactly this ecosystem we are talking about. So this ecosystem, in a way, is it a familiar to us, or it is something very different? So if we see a digital ecosystem, the IoT is a smart home or wearable watch. All these are the example of a IoT system. They are sending the data to the cloud, and in these there are sensors deployed on our body or in the house, and we can operate those sensors. We can see the live data on our mobile application. This is this is a simple that way, and the same is now we are trying to implement in the agriculture in the terms of IoT. So when we are implementing in agriculture, definitely we will require communication network, cloud for storing this data, analysis, processing of the data, and decision support system through user application. So if we see this end-to-end stack of the IoT and AIML, are we familiar with some of this technology, or are we using some of this technology? Definitely yes, we are familiar with the mobile apps, web apps. We are using it from years. So implementing it for agriculture should not be that critical. Same with a server, Same with a communication network. Now the networks are coming into the drone. So then what is most critical is these things or the hardware which will be there on drone, which will be there in the fields, and which will be used by the farmer. So where we could succeed is a secure digital payment, advanced communication, AIML, Industry 4.0. We have already shown success of IoT technology, AIML technology in all these domains. But if we see these domains or these application area, they are in the well-versed under the well-versed technological crowd was handling or is handling it. This is not the case when we are coming to the agriculture. And that's why, because our customer or user will be the farmer. And that's why we require specific design requirements are there for things. First of all, a miniaturization. We cannot have a very bulky system on drone or at a field. The system has to be efficient. Not only computing efficiency, because we would like to have a edge computation. So AIML at edge, AIML at device. So computational efficiency we require, energy efficiency we require. Also carrying a very heavy battery will not be a good thing, even for drone or IoT systems in the field. So battery less, can we make a system battery less? Accuracy and reliability is another thing. It has to work in the outdoor environment. It has to work in the sustainable climate. It has to be so. And the crucial thing is a cost effectiveness, because considering the customer requirement. At the same time, it has to be secure. So self-identification should be there. Again, when we see sustainability, maintenance of hardware is a crucial. Just consider acres of land, acres of villages, many villages, such IoT systems or drone have been deployed. If there are challenges with respect to maintenance, will farmer be able to do it by himself, or does he has to run every time to some shop and get the service engineer at his farm? So we need to have self-testing, self-diagnostic, self-troubleshooting system. And how this can be possible? So miniaturization, of course, possible with the help of system on chip, thanks to advancement in the semiconductor technology and the indigenous development of now the production will be indigenous for these ICs. So advanced processor, this can definitely help us to give a better efficiency. Ultra low power devices are very widely used in wearable electronics, in Industry 4.0. We can definitely select to use the ultra low power devices in the hardware which will be building upon energy harvesting system to completely avoid the battery. So systematic calibration of a sensors would be required for reliability of or accuracy of the data. Of course, the certified hardware to attain the reliability. So for outdoor environment, it need to have IP67 or IP68. So certified hardware, certification agencies need to be there. For cost effectiveness, again, I said SoCs, system on chip, would be the most cost effective way. At the same time, modularity is also required, so that only one module need to be replaced. So maintenance wise also cost effectiveness is addressed. And when we see the self-identification, so it should have a IP protection. It should have a, we should select a processor and hardware such that it should have a inbuilt hardware safety, functional safety, and enable certification. So such kind of sub electronics components are available. And while designing the hardware, we need to focus on utilizing such kind of a component. So I will just give quickly one such use case which we have developed at TIH IoT, and the completely indigenous smart storage monitoring system, wherein we have created a local BLE network, and GSM is only with a central system. So central node has a GSM and local network has been set up with the help of a BLE. And now GSM needs to send a data maybe every 3-4 hours or even once in a day. And all these local systems, they have a computing ability, they have a data storage ability. So that way we can reduce the bandwidth requirement for sending the data. And we have tested this for various like onion, potato, mango, and that way we could achieve communication efficiency, energy efficiency. The battery lasts around 2 to 3 months, though it is we have tested means for 2 to 3 months, and it could last for that time. And it is easy to operate. A very handy system. You can see it. It can be holded in the hand and can be easily deployable, removable. That kind of a system. We already done some field trial at Abona, and yeah. So as I have already covered, it is an energy efficient, communication efficient system. So what are the challenges we need to address upon, or we are currently focusing? Are accuracy of the sensor, soil specific sensor calibration, repeatability across the sensor, so that we don't need to calibrate every sensor for every soil. So repeatability of the soil sensor is a crucial thing. Again, as discussed earlier talk, there is a variability across agriculture practices with respect to soil, crop, geographic condition, climate condition, with respect to Rabi season, with respect to Kharif season. So incorporating this variability and management of a big data, that is going to be the challenge ahead. Of course, with the help of so this is our digital agriculture field, what TIH is working currently. And we have agri stations for crop soil monitoring, entire weather monitoring. We are developing the drones for spraying. We have a smart storage applications also. And through this, we are expecting around 20% reduction in fertilizer, 50% reduction in irrigation water and pesticide usage. At the same time, 10 to 20% reduction in the wastage of the crop at post-harvest. Again, a harvesting cost also reduction, and thereby there will be a improvement and improvement in the yield as well as the quality that we are trying to build upon. And these are our devices, what we are already developed, and not only prototype, but they have been deployed in the fields, and we are working. And one such system is a Sambo system. I will talk more about it tomorrow. But we have, again, for this system, we are using one Sambo system. Since if we see the weather data, that weather data doesn't change across say 5 to 6 kilometer area for specifically for agriculture application. So we can have a one weather system, which is a Sambo system in that area. And we have set up a network of a LoRa WAN, which can access that weather system or weather data. So that way, we are trying to have a sustainable hardware option, or reducing the requirement of hardware. And through the mobile application, we can collate or integrate the LoRa WAN as well as the GSM technology together in the Sambhav and so on. So we have deployed it, and I would like to thank for giving me this opportunity, and would like to end. Definitely, a multidisciplinary comprehensive approach is required. And as we say, like digital life is possible, and we have lived that life 4 years before, and now it is a need to bring all those technology in the agriculture for a sustainability. Thank you.
Thank you, madam, for taking the double time to. Now, without giving any introduction, I request Ruby Patania, Senior Program Officer, Vadhavani AI. Just, madam, to not take more than 10 minutes, because everyone has taken your time. And if after that, we will have some to distribution and then lunch break. What is yours?
Thank you so much. I'm not taking much of your time because I think the speakers have covered almost all the things, whether it is related to the opportunities in the AI sector or the challenges which we are facing. And I would really appreciate and congratulate the ICAR, who is doing a tremendous and great job in agriculture field. And we also feel proud when we are standing here in their premises and talking about agriculture. So really appreciating this, sir. I I'm also, having a background of agriculture. And then I came into a decade of experience giving the sustainability and agriculture as an AI nowadays. So that's really a great experience for me as well to listen to all of you. And I represent here Vadhvani AI, Vadhvani Institute for Artificial Intelligence. And as we know, all of us know that the AI has emerged as a transformative force in agriculture, offering a tremendous wave and a new wave in innovation and the efficiency. So if we talk about the AI innovatives in Vadhvani, we as in the whole family of Vadhvani is like into agriculture, education, and in health sector. But mostly talking about agriculture here, we are dealing in a number of solutions which are being deployed and implemented at field. We are closely working with the state government, with the center, and with many of the partners with the support of ZIZ and other funding organizations. We have implemented solutions at the field level, and we have reached out to the farmers as well, rigorously working with them over the design, with the user UX design and all, and then implementing those solutions to get the successful and the best output of the AI solutions which we have implemented. We actually foresee the innovations in future as well. And if we look in future, I think AI will continue to play a centric role where in shaping the agricultural landscape, the sustainability, fostering and addressing the challenges of the food production in the growing, global population. We talk about the AI innovations. We develop certain innovations in Vadhvani, which we have implemented, where we have the decision support system. We come out with a cotton solution from past 2-3 years. We have implemented it successfully, and now with the convergence model, we have incorporated these solutions into the National Pest Surveillance System, where we are closely working with the center and with the ISRI as well. Yeah, definitely. This is for the informed decision regarding the crop selection, planting, schedule, and resource allocation when the farmers, get a solution onto their hand in their regional languages and can see what are the, signs of the early pest detection in their field. We have specially designed it for cotton, and then we are growing up for the more crops. When we talk about precision agriculture, I think AI enables the precision monitoring and management of crop, soil, and other resources, optimizing the inputs such as water, fertilizer, and pesticide. We also come up with the slide which shows is like the National Pest Surveillance System, where you can see the problem statement solution. We can develop the AI model, the rejection model, and then the detection of the pest. Especially this is designed for the PVW and ABW, and then we have expanded it to a number of pests and diseases as well. And then this will be definitely merged into a whole solution for the farmers and be used to at the national and the state level. So we have another solution, which is Agri-AI Collect. We usually call it as a digital farmer diary, because we know that whenever the solution get implemented, any sustainable solution implemented at the field level, there is a requirement of data. And data is very important and crucial part in order to showcase the impact of any of the program and projects to be on ground. So we have this particular digital farmer diary where we come up with the automatic speech recognition model, and image detection and text extraction model. We want that the real-time data should be captured from the field, and it could be utilized in many ways. It can be, help in the yield prediction as well in certain point of time. And with the real-time data, AI algorithm can even analyze the historic data and other environment factors to provide the prediction, crop yield, market trends, and weather patterns, etc. So as we know, there are certain ethical concerns when the AI is concerned. So AI algorithms may raise ethical concerns related to data privacy, ownership, and the potential misuse of the sensitive agriculture data, which should be, kept in mind before going ahead with any of the innovations in terms of national and the state level, and for the policy level as well. If we seek the innovation, like in conclusion, if we see if there we have the emerging technologies and which are having the promising, opportunities to enhance the productivity and sustainability and resilience in agriculture, but they also pose with certain challenges related to data security. So in order to address all those challenges, I think there should be a collaborative approach among all the stakeholders who are involved in agriculture domain, where these could be the agriculture ground level players, the farmers, the implementing partners, the researcher, policy makers, and even the technology partners. They should come up together and to ensure that there should be a responsible adoption and implementation of these technologies in agriculture. There are certain points in the speakers they have very well said, like Arjun have mentioned the gender inclusion, like women plays a very important role. And I think the government also take initiative in developing a lot of schemes and providing, capacity building, hand-holding supports to farmers, like Krishi Sakhi are there, then Drone Didis are there. And they are our main focus. And I think if we include the women, there should be a much more progress in terms of innovation which has to happen as per the implementation and as well as the adoption of the technology. So I just gave a closing remark from my side. Thank you so much.
Thank you, madam. You have exactly taken time allotted. Thank you very much. That randomly happens. So friends, now we have completed, and fortunately, rare of the rarest, that all the speakers were present. 100% presence very rarely happens in any conference for presentations. So now we have all the speakers spoken. If we can discuss for 5 minutes, if pertinent clarification, if you can take name of the speaker and then clarifications out for. Only 5 minutes is allotted.
Today. Yeah, my name is Vimal Vaklu. I'm the former CMD of TCIL. Actually, I have a question. Of course, I have a number of questions, but since you have mentioned only 5 minutes, I'll start with Nachiket. You mentioned about use of, for example, blockchain for agriculture. What is the primary use of that? I mean, for agriculture, which is not being addressed at present.
We are contemplating the use of blockchain in a transportation or handling of a particular crop. Where a crop, let us say banana, like at present we have taken, when it starts somewhere from south and it is intended to reach maybe Madhya Pradesh or maybe Kolkata or maybe some other places. When in the transportation itself, we are first, number one, we are monitoring what are the different micro environment and quality of the product. At the same time, there are demands coming from various places. It could be prices fluctuation is another thing. Then weather data is coming, that it is telling from different places what type of weather and what type of climate is there, and how that might affect the trucks progression, even some kind of traffic related information coming. So all these fragmented information as big data that can come as a different blocks, and a chain can be made for taking decisions.
Actually, the reason I have asked this question is this particular event is being organized under the aegis of ITU. They also have a focus group on environmental efficiency, where they look at ways and means, that's one of the objectives, to see how all these technologies, the environmental footprint they leave on the Mother Earth, that also is taken care of. And to use them selectively so that we don't, when there's a blockchain company, they'll try to use blockchain in everything, including monitoring of toilets. But the issue is, do we really need it? And what you mentioned right now, all these applications, you don't need a blockchain. It can be simple tracking if you have to monitor the quality of the produce, taking from one location to another. You need a simple maybe monitoring system. Even the IoT system plain is, because blockchain is very, energy, you can say, a real energy guzzler. You need to be careful about it because through all these discussions, to make it, short, I understand that we are very keen on using all sort of technologies, but we are not addressing the basic challenges which agriculture is faced with. The idea of this event basically, I think, is to see how we can save on water. That's why
Dr.
precision
Madhavan, this is
agriculture and
open,
other
open,
things.
open
But
discussion.
if we, because for even blockchain, you need a lot of water to cool down many things.
All right.
So, I mean,
Yeah,
we
okay,
need
okay.
to have a sort of a.
Yeah, thank you. You
Yeah.
made your point. You made your point,
Yeah.
and
We
yes,
can
that is
discuss
also,
during the lunch, we can
that is
discuss during
also,
the open, which is a primary requirement, more important. Of course, the more important should be taken up first, then second important, but everything is important. Once word the important, then everything is important because food itself is an important. If you just manage the water and food is coming, but if you are not managing properly and quality is not maintained, raw material is important. Good quality raw material, good quality milk only can produce the good quality khoa and the sweets. So that is important, everything. We can discuss later on during the lunch in details. Any other person having impressing? Yeah.
Hello, this is Safa from Iraq, CMC Iraq. Sorry, I'm actually like to asking about all the discussions and talking about the infrastructure and mobile network that will be used in IoT or IoE or whatever. But we don't talking about the user experience, as you know, on all the in agriculture, we are talking about the farmer and also about the little experience with using all of these technologies. So I don't know actually where is this point in these discussions and points. Thank you.
I think Dr. Rai will respond.
No, actually, you are very right. We have tried to implement technology at the farmers field, and we have taken the user experience. If for some of the crops like vertical farming and protected cultivation, it's very good. It's very positive. But for other areas, the cost of technology is a major hurdle, so they are not able to afford it. Otherwise, the saving of the resources, um, uh, management of the cost of production, reduction in cost of production, in long term, it is good. But normally in India, I'm talking about Indian condition, basically for protected cultivation, vertical farming, high value crops, they are very well adopted, and there are a number of startups and there are a number of areas covers many states covered. But for other technologies, still we are trying to do the economic analysis of the cost benefit analysis we are trying to do. That's what. Thank you.
As I had said during my introduction, some of this, in particularly micro irrigation systems, we have deployed many places. And most of the case study during related to this workshop will be discussed tomorrow. I think many case study which has been deployed in India, those will be presented there, and I think you can see. But you are right that most of the technology are not deployed at present case. Most are we are talking or we are only in developing phase, some of them. Any other question?
Thank you, Chair. I just want to mention, and of course, it is a suggestion only. So far, we have been focusing on technologies which is for big farmers. In India, as well as globally, vast majority of farmers are marginal farmers, and we know that we cannot disregard that because that provides sustenance. So perhaps we will have to devise technologies for them, and we have to go ahead. Thank you.
Correct. So with this question, this is your suggestion, that is correct suggestions. And we are aware of that. Friends, in India itself, more than 86, 87% farmers are marginal and small, less than 2 hectare lands. And maybe 97% of that is less than 1 hectare lands, plot size, maybe further less. These are the holdings by the farmer, but if you go by plot size, then it may be much lesser than that. And of course, we should develop all the technology, machines, and whatever. I do not know how many. We all say that we are working for farmers. How many farmers have come to us to tell that please develop for us? Hardly any farmers come. We anticipate that these are the requirement of the farmers, and hardly any farmers receive that requirement in right sense. We are doing our job, and we are saying that the farmers, we are working for the farmer, but we are working for our own sake, I think. Data source, data acquisitions, data communication, whatever presentation, 90% I think presentation today also are only the information technology, neither AI nor the IoT, you can say. AI and IoT, I think AI is being totally misnomerly used by the people. The 20 years back, which we are doing the modeling and prediction, forecasting, that is supposed to be now in new words. Most people are using artificial intelligence as a buzzwords. Artificial intelligence actually is something like your brain can think and then give some results. But hardly, I don't say that people are not doing, but very few. India is fifth largest country in the research, in AI related research publications. And also in robotics, we have around third, fourth positions, but in initial stage, no country is in position of complete deployment of this technology. All are buzzwords working, but as you said, that because of the poor farmers, small land holdings, it is not deployable. And I personally feel that the requirement of small machines, small gadgets are required for them, and those can be in terms of robots, because the farmers in villages are reducing number, as Dr. Nachiket had shown. In India itself, by 2047, we will have only 35% person left for doing the agriculture. And out of that, 60-75% will be the women. Then who will do the agriculture, and land fragmentation will be further. So for a smaller one, a small labors means robots is required, and those robots should be loaded with this AI and sensor. Everyone is talking for the development of apps, development of gadgets, small, but no one is talking for the sensor. Sensor is required. Most of these sensors are developed in the other country, and India and Indian subcontinents, hardly we are producing any sensors. So these kinds of AI, IoT will be just for information technology to the farmers in their mobile till the sensors are not ingeniously produced. We have developed autonomous vehicle our own. We have developed our own robots for weeding, but not yet deployed. But in IoT is very much deployed in the irrigation system. And smart crops, of course, you see how good will be if some crops will cry, and that crying sound will go to your ear that I need water. But hardly that kind of IoT has been developed. And I need water, and then that farmer should not go there. Automatically, plant should apply the water. But up to that extent, we are not doing that. And post-harvest processing, quality, of course, Dr. Nachiket covered some quality aspect. But it is required, it is much required that is blockchain technology you can discuss with me or through him. Also in supply chain management is very important, because nowadays, I remember in 2002 when I sent a research paper on milk adulteration in some so-called developed country, they said that please publish this in the world corner where this kind of things is happening. Now I see that how many papers on food safety, quality using sensors are coming out from those countries. So slowly we are moving that. But friends, this country is moving at very faster rate, very faster rate. In 2000, no one was thinking that this kind of Internet of Things, robotics, sensors, and automation in agriculture. But now we have gone a very fast rate at our distance we have covered. We have very less time, and we have to develop everything by, you can say, 2040 or 2045, so that our deadline of development of agriculture, not only agriculture, everything, should be par excellence by 2047. Digital platform, Dr. Rai has said that Kisan Sarthi as a form of information. It is a revolution in Indian agriculture given by the ICR and all the SAUs, that system, our research system. Dr. Shirohi presented 5G, 6G, that is correct, it is required. But even then, we are not able to develop some simple kinds of spectrometer, NIR spectrometer. I personally feel the box which we talked, that is very much required for local area, local network area, even in the home appliances, it is required. And agriculture is required. But see, what I see personally, that one set of personal electronics, electrical and sensor technology scientists are there. One set of scientists are agriculture, science, and technology people are there. But both group of people are working very hard to simplify, to help develop the agriculture at faster rate, using all the technology. But both are lacking something. Both are lacking something, that one is lacking electronics, electrical sensor technology, others is lacking knowledge of agriculture. Many times people see that agriculture is very poor subjects, very easy subjects. But I personally feel that Shirohi sir has itself presented that it is difficult, varying nature. It is most difficult. Even many times I personally feel that it is difficult than the atomic science, because in atomic science most of the time you deal with the dead material which never change. You keep in the lab, it will remain like that only. But in agriculture, you go to the field, see, and tomorrow, and after 2 hours maybe something else. So handling the agricultural material before harvesting, after harvesting, and predicting them, really it is a Herculean task and very difficult. So we have to search a very right discipline, very right persons to employ who knows both engineering and agriculture much better and easier to develop these fields very fast. With this word, I thanks to the organizer to give me this opportunity to handle this session. It was very educative, and I hope that things will go long way, and we are developing very fast, and things should be done as our government wants. Within the period of maybe 10, 15 years, everything will be employed, at least in part of the Indian agriculture. Thank you very much.
So I would now like to request the moderator to present the mementos to each of the speakers. We will call on them one by one. So first we have Mr. Mihir Dakwala. Next we have Mr. Arjun Venkatraman. Nachiket Kotiwale. Dr. Rabi N. Sahu. Dr. Anil Rai. Professor Krishna Sirohi. Dr. Ashwini Gajarushi. Ruby Patania. So thank you to all our wonderful speakers and to the moderator for taking us through the session. I will now pass the floor to Mr. R.S. Singh to present the memento to Dr. Shyam Narayan.
अच्छा अच्छा फोटो यूज करना चाहिए अब वो जमाना गया
So thank you, everyone. We will now break for lunch, and session 2 will begin at 2 p.m. Indian Standard Time. speakers. So ladies and gentlemen, if you could take a seat. We would like to start session 2, which is on seeds of standardization, nurturing digital inclusion in agriculture. So for this session, I would first like to call the esteemed moderator, Mr. Song-Sing Shen, who's a senior IT officer at FAO. So please, if you could join us on the stage. He's now leading the agroinformatics team and activities at the FAO, and also focusing on cutting-edge technologies, including AI. So over to you to carry us through this session 2.
Thank you, Michelle. Good afternoon, ladies and it's my pleasure to be here to moderate this session. So just as Michelle introduced, I'm leading agroinformatics team in FAO Food and Agriculture Organization, the United Nations. In the recent years, disruptive information and technologies like artificial intelligence, Internet of Things, and big data and so on, been widely adopted in agri-food system for higher productivity, better profitability, and better sustainability with digital transformation. In FAO, in our 2022 to 2031 strategic framework, prioritize 20 priority project areas. So one of them is digital agriculture. So we want to use this advanced digital technologies to promote digital transmission in agriculture worldwide. So agri-food system, from field to fork, a complex system with many components. Digital technologies have been applied in different sectors and components. How to maximize the technical benefit with information sharing, integration, and interoperability? We have challenges in standardization. In this regard, many agencies have started the work, including international organizations like FAO, ITU, and national institutions, and non-government organizations and private sectors. In this session, 5 groups of speakers are invited to present their relevant experiences in standardization in using artificial intelligence and Internet of Things in agri-food system. First, let me introduce our speakers and invite them to the desk to take seats. The first is Dr. Namita Singh, Director of User Experience of Digital Green. Dr. Singh, please take your seat. And the second speaker is Mr. Debasish Mahalik, Science of Bureau Indian Standard. Mr. Mahalik, please take your seat. The third group, we have 3 speakers. Dr. Basat Das, Director of ICAR CAFRI, Kolkata. Welcome. Mrs. Chena Yana, Science for ICAR CAFRI, Kolkata. Welcome. And Dr. Mahanti, Scientist for ICAR NDRI, Kana. Welcome. And the fourth speaker Dr. Sanat Sanraji, scientist of Digital Food Initiative Group, Tata Consultancy Services. And the fifth speaker, Mr. Sushil Kumar, Additional Director General Telecom NELSA. Welcome. Okay. We have very limited time for this session. I understand each speaker have a lot of content to share. We have only 2 hours. So could I request each speaker, each group of speaker to finish your presentation in 20 minutes so that we will have some time for questions and comments and feedback from the audience here. I think that's a very valuable part of our workshop. So I try to remind you if there are only 1 minute left, you should wrap up to the conclusion and finish your presentation. Thank you for your cooperation. Without further delay, maybe we may ask the first speaker, Dr. Xin, to start your talk, please.
Hi, good afternoon, everyone. It's a pleasure to be here and talking about the work that we are doing at Digital Green along with the Ministry of Agriculture. So we are essentially building a digital public infrastructure along with the Ministry of Agriculture. And the main purpose of this DPI, because you've definitely heard about like other DPIs that are being built in agriculture as well, like AgStack, for instance. A couple of speakers had sort of like mentioned that. This is in a sense to provide an AI assistant to frontline extension workers and smallholder farmers themselves. So the main purpose that this DPI aims to solve is access to information. I think most of us are fully aware that access to information remains one of the key issues that smallholder farmers in India continue to face. So before I get into what Vistar is all about, the DPI that I was talking about, in brief about Digital Green as an organization. So we are a tech nonprofit organization who've been in this field for the last 15 years. And when we started working 15 years ago, one of the key sort of like findings in the agriculture sector was that smallholder farmers typically tend to listen and understand their own peers. They would trust that source of information much more than any other source of information. And that remains largely true even now. That is what Digital Green started like building its model on, which was community-based videos. So these videos were being produced by local extension workers. They featured model farmers in that region. And these videos were also disseminated by farmers themselves, often who worked as frontline extension workers. And in that model, the key part was that the entire scientific knowledge that really exists, the technical knowledge, was being converted into a form that smallholder farmers could easily understand and therefore easily adopt as well. So how do you take something that is highly scientific, highly technical in nature, and make it understandable for a smallholder man or a woman farmer? And through that process, we along with our partners, made about 7,000 plus videos that are there in several local languages in India. They are also all on YouTube, and it's surprising to actually see that these highly localized, videos in like local dialects have been watched by 80 plus million people, and obviously only a rural audience going to be interested in something like that. And around 100,000 extension agents have also been trained in both developing and disseminating this localized content. And out of the 6 million farmers that we've reached, 60% of them have actually been women themselves. And overall impact has been just increasing the cost efficiency of the agriculture extension system. But a lot of this model was, a lot of it was offline, continues to be offline as well. So do most of our farmers, even till date, especially women farmers. However, we did see an opportunity to leverage more cutting edge technology to improve the entire extension effort. And that is when this, a part of this entire DPI is an AI-based chatbot, which I mentioned. So the AI-based chatbot is just one of the use cases that we're anticipating to be a part of this. The key areas for us, one, like I mentioned, was increasing efficiency of it. How can frontline extension workers reach smallholder farmers effectively? Even till today, often there are cases where each extension agent would have up to 2,500 farming households. So you can understand it's nearly impossible for that extension worker to reach each and every farmer with information on a regular basis as crops change, as seasons change. And how do we ensure that that frontline extension workers' efficiency can actually increase, where they do have information as and when they actually need it, and they can share it with farmers as and when it's needed. Another key bit is making sure that that advisory is actually actionable. Smallholder farmers live in a lot of resource constraints. So how do we, again, ensure the technical knowledge that gets developed in all our agricultural research institutes, et cetera, is something that a smallholder farmer can understand and apply. So it's not just about the language being local, but also being explained in such a way that farmers can understand it. And that's where the whole natural language part actually comes in. And in all of this, looking at a governance model where it is led by the stakeholders, not by any one stakeholder. So stakeholders and partners are what lead the governance of this. And ultimately empowering extension agents to deliver results and amplify farmers' voices. Now that also remains an important part. So it's not just about like sharing information with them. It's also actually collecting feedback from them on a continuous basis, what is working and what is not. So forming a sort of a bridge between smallholder farmers and scientists to say, can a certain method or can a certain technique actually be adopted in a way that will work for a smallholder farmer? So ensuring that there is that real-time feedback loop for what is working for farmers and what is not. So this is kind of the stack that looks like for Vistar. At the bottom layer are open tech building blocks. Again, in the previous session, also a couple of speakers did talk about how a lot of companies are nowadays leveraging open stacks that are available. Then the content consumers themselves, the frontline extension workers being one, and farmers also being other content consumers. There is also network orchestrators like the Ministry of Agriculture for Vistar, who are the ones who are actually enabling all these different partners and players to come on board, and content suppliers, which are ICAR, the other state agriculture universities, the KVKs themselves, because a lot of time the Krishi Vigyan Kendras at the local level are the ones who are also adapting that information to meet the local needs. So these content suppliers at various sort of like levels as well. And what we're also ensuring is that it's interoperable with other DPIs in India that we're building. Bhashini, for instance, AgriStack, ONDC, etc. as well. Till now, Vistar has been pilot tested in 5 states, Bihar, Uttar Pradesh, Odisha, Madhya Pradesh, and Rajasthan, and 5,000 extension agents are actively using it. As of now, it was just put in the pilot mode 3 months ago. And the plan is to eventually reach up to 500,000 farmers in the next 1 year. So to just give a better idea of the network governance that we're looking at is, like I mentioned, the network stewards in it, led by the Ministry of Agriculture. And the reason for that is that in agriculture specifically, the trustworthiness of the content is really crucial. That technical information has to be absolutely correct, what is being shared with farmers, so that
that content is verifiable. It can be traced back. So if a farmer is receiving anything, any advisory via a chatbot, one should be able to figure out what is the source of information, and that information is verifiable. So that is at the core of what the network stewards really do. The content suppliers, like I mentioned, a lot of them are government partners themselves and agricultural research institutes, and content consumers, the State Department of Agriculture also being consumers themselves. And when I'm saying content, it's not just advisory content, it's also the feedback that's coming from farmers, right? Like we are also treating that as content. And eventually private sector and nonprofit organizations will also come on to this platform. I would not get into like a lot of detail of the tech part of it, but the 4 main components in it. One is the knowledge base itself. So I think the key difference here is that when this chatbot works, it is not retrieving information from the internet. It is retrieving information only from the content sources that are provided to it. And these content sources, like I mentioned, are coming from institutes like ICAR and other academic research institutes. So it's vetted at the very first stage. This knowledge base can be on a variety of topics and thematic areas. So it could be about like regenerative agriculture. It could be about soil and weather data, which is more dynamic in nature, which is changing pretty much every day, maybe pest and disease information, even registries and input and market data. So all these can be in the knowledge base. The interface functions. Now, this is where technology like AI, ML can actually be made applicable to smallholder farmers. So they are able to ask questions in local language, and they can either give a voice input or type it in their own local language. And what we're also doing is training our models to understand these local dialects better. So if I say Hindi is available, of course, different dialects of Hindi exist. So we're also training the model in actually understanding these local dialects. And when we're doing that, we're also ensuring there is 50% participation of women farmers as well in providing that voice data. So the model's able to understand both men and women's queries, right? There is the response which comes in local language too. So if you've asked a question in Telugu, you would receive a response in Telugu in that particular dialect as well. And that response is also provided in text, voice, as well as wherever video exists on that particular topic. For example, the 7,000 videos that I was talking about, then the chatbot also retrieves that local language video, and that's shared on the bot as well. There are push messages that can be provided. So for instance, for extension agents to know that based on the crop calendar, what's the advisory that they need to start sharing in the next couple of weeks. So sending them push notifications for them to be able to plan their work better. And like I'd mentioned, also feedback on the responses they're receiving, because we're still in the initial phases of it. We're seeking active feedback from frontline workers on, how accurate the responses really are. And that's what's helping us fine tune the model as well. So this is just an example of how it can actually look like. The last part that I really want to focus on is the gender and climate lens in this work. So the way we're including gender is not just in terms of participation, how many percentage of women, but we're aiming to go much, much beyond that. So even when we're doing onboardings with Department of Agriculture in various states, for instance, during onboarding, we're ensuring that there is at least 30% participation of women frontline workers themselves, who in turn would reach more women farmers, more self-help groups, for example. Beyond that participation, also looking at whether the responses that are being provided are gender inclusive in nature. So are the responses, for instance, suggesting practices that do not require that much manual labor or do not require those many resources? Because we know that labor, access to labor resources, etc., are issues for women farmers. So is the chatbot providing responses that typically only male or large-scale farmers can adopt, or is it suggesting practices that a woman farmer with limited resources can also access and adopt? So again, that being like actionable information is a key part here. The same goes for climate smart agricultural practices as well. And this is where the government partners that are involved in this network are really looking at setting benchmarks for each and every response that's provided by the chatbot and ensuring that whatever practice is being suggested is a climate smart practice. And while we're doing that, along with these stakeholders, really establishing these benchmarks as well. So when we're establishing benchmarks for content quality, we're not just looking at the technical accuracy of the agricultural information being provided, but like I mentioned, also looking at the fact that it's gender inclusive, it's not biased. The tone of the chatbot, for instance, is not biased. It's not saying farmer brothers, right? Like we tend to say that quite often. And also has a very strong climate focus in the kind of advisories that are being shared. And eventually helping through these benchmarks for other content providers to be able to follow these benchmarks as well, to get their content on the network. So that's in brief what we're doing at Vistar with the Ministry of Agriculture, ICAR as well. Very thankful for their support and helping us work on this platform. So okay. Thank you.
Thank you, Dr. Singh. It's very informative presentation on this peer assistance system for digital agriculture extension. It's really, really important aspect. Thank you again. And then we go to next speaker, Mr. Malik. The title is Standardization in Smart Agriculture, the Way Ahead.
Okay, thank you, Mr. Chain, and honorable fellow speaker, dear participant, ladies and gentlemen. So good afternoon to all. It's a post-lunch session, but I will try to keep it very crisp, and I will try to not to be too much informative, however, not missing the point, because that is why we are here today. So it is a privilege to be here in this ITU and FAO workshop and sharing some thoughts on smart agriculture, smart farming. So the title of my session, as you can see, it is Standardization in Smart Agriculture, the Way Ahead. So my session will tell you a story of what the smart agriculture is, what BIS is, how BIS has transitioned from developing standards on typical agriculture machinery, typical agriculture aspect to the smart agriculture era. What are the contribution of BIS at national and international level of standardization, and some food for thought. So with that, let's go ahead. And this is the content, as I said, and these are the topics I'll be broadly touching upon. So the first thing, that is smart agriculture. So this is the time of, as many speakers in the morning session also had explained, this is the era of digitalization. So we cannot keep agriculture away from digitalization per se, or AI per se, or IoT per se. So today's world is driven by data. And based on data, we have to take some decision, right? That is why we have to analyze the data and take a decision. And if the quality of data or the process of decision making is good enough, then we can avoid the ambiguity such as volatility or complexity or uncertainty, etc. But do you think agriculture is just a simple subject? It is not. It is a kind of a combination and a kind of intricate web of different stakeholders present in the from farm to fork model. So this agriculture is typically the interaction between these different stakeholders. And when we are talking about smart agriculture or smart farming per se, we cannot rule out a single stakeholder from this whole decision making. Therefore, the definition of smart farming has been coined by the ISO SAG, that is the Strategic Advisory Group on Smart Farming. And the definition goes as such: the smart farming is data-driven, as I said, then principal decision-making in agricultural and food value chain, because we cannot keep both things away, because it is from farm to fork, as I said, the continuity in the complete value chain. And food value chain occurring as a multi-objective optimization in the context of global volatility, uncertainty, complexity, and ambiguity. So these are the factors this smart farming should address to. And the smart farming should be data-driven, and it should cover the complete value chain rather than focusing on a single stakeholder, such as producer or consumer or the service provider. So this is why the smart agriculture definition is such. So now the second part, that is what is BIS is all about. So BIS, the people who are from India and the people who are from outside of India, my foreign colleagues. So in India, BIS may be known as ISI because ISI mark was very famous. So BIS was earlier known as ISI because it was Institute of Standardization and Indian Institute of Standardization, and it was formulated in 1947. However, after that, in 1986 Act, it was converted to Bureau of Indian Standard, which is BIS. And in 2016 Act revision, BIS became the National Standards Body of India. So as National Standards Body of India, BIS is the official representative of India when it comes to standardization at ISO, which is the International Standardization Organization. So when it comes to standardization in the field of agriculture, the structure in BIS is such that it is governed by the Food and Agriculture Division Council, which is chaired by DGICR. And under that, we have a Food and Agriculture Department. And under that, we have, for specific aspect of agriculture, we have a sectional committee. It is basically a group of experts. Because standardization cannot be the job of a single stakeholder, right? One day, one researcher cannot come and say that I have done this research in my way and this is the standard how it should be. It cannot be. Because each stakeholder has their point of view, their perspective, and standardization takes care of all the multi-stakeholder perspective. That's why this expert group consists of researchers, academicians, industries, policymakers like from ministry, consumer groups, and farmers also, and farmer groups also wherever possible. So the main aspects that is covered under BIS for standardization are agriculture mechanization, both pre and post harvest, then irrigation and drainage system, agriculture inputs, as well as agriculture systems and management. So when it comes to agriculture mechanization, more than 300 Indian standard has been published, and irrigation, it's more than 40, then inputs, it's more than 400, and in irrigation, agriculture systems and management, it's almost 15. So these are the kind of standardization activity that is currently going on from BIS since 1947. And these standards are not only regarding a product specification, it is also test methods, it is also terminologies for guidance, or general guidelines regarding processors, services, and also design and dimensions. So this is how BIS is involved in the process of standardization in the field of agriculture. So then why suddenly we have thought of transitioning to smart agriculture? Because suddenly, if you can see, since last decade, I can say, a lot of researches has been happening in India and also at international front regarding digital agriculture. Then the second is the startup ecosystem. The startup ecosystem in India in terms of digital agriculture is booming currently. A lot of startups which are different kind of approaches to solve the problems at different stakeholder point of view throughout the value chain. They're also doing a lot of things. And the third and most important thing is that BIS has developed its standards national action plan, the kind of a 5-year plan for standardization of for the country India. And in that, the SNAP has identified this digital agriculture as one of the key points in order to develop the standards. And simultaneously, at ISO level, at international front, ISO has also developed the SAG, that is a strategic advisory group on standardization. So you can see that how the international interest and the national interest coincide with each other. And that's why BIS decided that we need to go for standardization of these technologies related to smart agriculture. So now the BIS focus. So as I said, what drives the BIS focus? The first foremost is the SNAP, that is a Standard National Action Plan. The second is the stakeholder consultation, because we go for several levels of stakeholder consultation with different kind of stakeholders. Then the policy integration, because the ministry, they also guide us, because the different missions driven by the schemes driven by the ministry, standard is a tool to implement that. So based on, in parallel with those schemes also, BIS develops standards. Then the factor that drive BIS, the last and not the least, is SDG, the Sustainable Development Goals. So that is why we are here today. Also, this workshop has a SDG, that is the SDG 2, if I'm not wrong. So similarly, BIS drive its focus towards standardization. So current subject, if you can see what we are doing right now, the first is the drone application. In the drone application, the two aspects that has been already been covered. One is the drone spraying system and one is the drone seeding system. In the drone spraying system, you can see we have taken from the safety aspect, the operational aspect, and the testing aspect and the general aspect. So it is kind of a guidance document for a manufacturer of the drone for this application or user of the drone for the spraying or the seeding application, as well as the auditor or the policymaker, the compliance person, the conformity assessment person. They all can use this single standard in order to regulate or the monitor or to manufacture or to use the drones for the agriculture purpose. And second is the urban farming. In urban farming, because this is the need of the hour and we have a space constraint, we have the resource constraint, and urban farming is kind of a solution to those aspects. So hydroponic, then artificial lighting system for protected cultivation, then use of IoT and sensor-based application in the protected cultivation structures. So BIS has developed standards for all of them and it is currently under wider circulation. So all can I will request everybody to kindly go through BIS website, and as this is under wider circulation, you can access the draft and you can also provide your comments because currently the drafts are open for commenting. Then the remote monitoring and control system. In the morning also, our Honorable DDG Agriculture Engineering has mentioned regarding a lot of case studies has been successfully happening, the use of IoT, AI in the automation of drip irrigation system. So BIS has also taken up the task of developing a national standard in remote monitoring and control system. And at ISO also, international level, BIS is contributing in developing the same standard which is being developed in parallel. But however, the national standard is taking consideration of the national interest of the farmer and the user accessibility and usability of those aspects. Then comes the last and not the least, the autonomous part. The autonomous self-propelled agriculture machinery. In ISO, India has contributed in development of ISO 18497. That is the autonomous machinery for agriculture standard. It is in different part. It covers the requirements such as safety, the principle of design, the possible hazards, and how to prevent it. So these are the main four aspects you can see that in terms of national standardization, in terms of digital agriculture is concerned, and BIS is taking care of all those. So now the international and the national contribution of BIS. So as in the beginning of itself, I said that this digital agriculture is not only about regarding farmer or not only regarding the consumer who is at the latter end of the food value chain. So digital agriculture is kind of an intricate wave, right? It is the combination of different interaction between different stakeholders. So ISO also understood that at very early stage, and that's why ISO thought of developing this ISO SAG, Strategic Advisory Group, and the ISO TC 347, which is the technical committee at ISO, which is recently formulated in order to take care of standardization related to smart farming and smart agriculture. So India's participation is that India was member of the core committee as well as all the 9 sub-core committees covering the different aspects such as crop production, livestock, urban farming, etc. And as a developing nation and agrarian nation, we had always the concern and we had the perspective that we have small and marginal farmers, we have the cost-sensitive consumers of the technology, and we have so much of diversity when it comes to agroclimatic zone and land pattern also, and the soil quality also. So our concern is not same with the other member countries who are present at ISO in this TC or SAG. So we had always that concern regarding that, and we had also successfully raised those concerns in that. So currently after that, now when the ISO TC 347 has been developed, in that ISO is also considering the representation of developing nations as a separate entity rather than the members who are the regular members of the committee. So developing nations representation in this kind of technical committees will definitely try to solve the issues of small and marginal farmers and smaller stakeholders. So now the challenge is in the standardization because BIS is the national standards body, and we are now in the phase of developing standards in the smart agriculture. So we had a lot of issues. The first and foremost is the most common one. Since the morning we all are discussing regarding this. That is the small and marginal farmer conundrum. We have to take care of them. And simultaneously, you have to also align our national standards with the international standards. So there is some gap that is coming, and it is very difficult to maintain the balance between the international requirement and the national requirement, because we have different issues and the whole world has different issues. The large farmer issue and the marginal farmer issue is different. So in order to that, our standard has to be somewhat flexible when it comes to national standard rather than international one. The second is the lack of quality data for standardization. When I'm saying quality data, I'll just give me an example that we are talking about the structure, the design structure of a greenhouse or a protected cultivation structure. So in India, as per Planning Commission, we have 15 agroclimatic zones, right? So they have different wind pattern, they have different climatic conditions, they have a different diversity of agroecology. So when we are standardizing the requirement for design and dimension of a greenhouse structure, it cannot be same for Kanyakumari, it cannot be same for Northeast, it cannot be same for New Delhi, it cannot be same for Orissa. So that was its issue that we are facing, how to standardize those data. So what BIS has done, that BIS has taken up a R&D project to collect the data, existing data, and as well as conducting a internal experiment by simulating the agroecology condition in order to come to a consensus that what should be the design and dimension for different agroclimatic zones. So this is kind of an issue that we are facing in terms of quality of data. Then lack of required expertise in smart farming. When I'm saying expertise, I'm not talking about the people who are present here, because they're definitely expert in this field. The expertise when I'm talking about, because standard is not the word of an expert or not a word of an industry. It is the word of the farmer also, the word of the FPO or farmer producer group also, it is the word of a consumer group also. So those stakeholders who are not that much expert in the field, so we are sometimes facing issue in collecting the information from them. Then the simultaneous focus on sustainability as well as smart farming. So we have a focus on natural farming, we have a focus on organic farming, and similarly, in the same way, we have another step of ours in the field of smart agriculture. So sometimes they both contradict each other because some of the practices, some of the concept in regenerative agriculture practices don't require any equipment to be present there. However, in the smart agriculture, when we're talking about, it is the inclusion of different equipments, the modern technologies. So somewhere we have a kind of a conundrum between these two. One side we have sustainable agriculture and another side we have the smart agriculture. So with that, the last slide of my presentation is the food for thought. The question of the hour. The question of the hour is, as I was saying, the last point. One side, we have the sustainable and regenerative agriculture practices. However, other side, we have smart agriculture technology. So the solution can be an integrated solution through standards, because standards are tools in order to address the different guidelines, different specifications, different test methods. But the question is, how to integrate this sustainable agriculture practices and smart agriculture technology? Or if there is an integration is present, how to identify that? So this is the question I want to pose to all the audience today present here, the participants, because this is the issue as a standard making body we are facing on day-to-day basis. And I want to give two examples and one success case, one a question where there is an issue we are facing. In Gujarat, there is a concept called hyper-productive natural farming. Hyper-productive natural farming, what the startups are doing, they are helping the natural farming farmers to use the IoT and AI to ease their decision making and ease their weather forecasting, ease their data management. So that is how they're helping the farmers in a way to improve the productivity of their natural farming processes. So that is one of the success case. However, I will quote another case where, for example, we have a drip irrigation model. And drip irrigation model, if you automate it, it is kind of going to be a smart agriculture technology, isn't it? So once you are using this drip irrigation model in organic farming or natural farming, in order to declog the pores of this drip, what we are using, we need to use chemicals. However, the chemicals are not, it shall not be used in natural and organic agriculture. It is banned because it is restricted. If you go through the standards of organic farming or natural farming, these chemicals are restricted. So in that area, whether we should go for a regenerative agriculture or sustainable agriculture practice where you have to use the biological declogger, which is very high cost, or we should stick to our traditional drip irrigation, declogging through the chemicals. So this too is kind of a contradicting with each other, but we have to find a integration solution. So the solution, it can be that each standard that we are developing now, we are looking from a lens of sustainability, as well as we are looking from a lens of the smart agriculture, so that from the beginning of standard development, this thing should be addressed. The second is when the cost factor is coming for the adoption of technology, the group or the collaborative effort like the formation of FPOs or SSGs or the cooperative farming structure, we are promoting that because we are mentioning in our standard that if this is there, it is a kind of a guidance or advisory that to adoption of technology, a group of farmers should be there or some in similar direction. Then the third is the conversion of researchers to the standard. That is a request also to all the participants because the artificial lighting requirement for protected cultivation, that draft standard is developed based on the research that is being done at CPCT IRI. And Dr. Murtaza Hassan has helped a lot in developing the standard of regarding that subject. So this is the example that how the ongoing researches can be converted into national standard for the betterment of the different stakeholders. So this is one of the solution, but still the question remains the same. These are the probable solutions that I, as a national standards body, came to my mind and I posed to the participants. However, the question remains the same, whether to how to integrate the sustainability with the smart agriculture. So with that, thank you, and that's all for my.
Thank you very much, Marley. Thank you very much. Okay, just now, Ms. Marley gave us a very good perspective, insight from the expert of standardization. We really need your help with us for the wider adoption of smart agriculture. So keep working with us. Thank you. Sure. Then for the third group, we have 3 speakers. But for even we have 3 speakers, we also have 20 minutes. Please share the 20 minutes between 3 of you. The first deliverer is Mrs. Jana. Go ahead. The topic for their presentation is smart technology for precision agriculture and livestock farming.
A very good afternoon to all the delegates of this workshop and namaste to all. So first of all, I would like to thank ICAR and DOT for giving me this opportunity to be here and sharing this space. So today's talk is smart technologies for precision aquaculture and livestock farming. As already said, this topic will be shared by 3 speakers, myself and Dr. B.K. Das. We both of us will be addressing the precision aquaculture aspects, and Dr. T.K. Mohanty, he will be addressing the livestock farming. In India, Blue Revolution has happened during 1985 to 1990. So to promote the fisheries sector, to get the double income of the fishers. Dr. Hiralal Chaudhary, he is regarded as the father of Blue Revolutions in India. He is the architect of induced breeding, and it means it is the architect of induced breeding. So from since then to till today, fishery sector has seen the tremendous growth in the fishery sector, but still we have a gap between the demand and supply because we have a huge expectation from the fishery sector. So before going to all the details, let's have a look some scenarios of India in regards to water resources as well as the fisheries productions. So from India accounts for about 18% of world populations, but we have 4% of world's water resources. So from the statistics, I can see, or I can say that India is blessed with the vast water resources. It is spreading from north to south and west to east. It is having the coastal line is about, it is more than 8,000 kilometers, and it is having the exclusive effective zone is about 2 million hectare, and continental shelf is about 0.5 million hectare. Besides that, India is bestowed with the vast open water resources in terms of rivers, canals, ponds, and reservoirs. So for rivers, we have 8 major river systems with more than 400 rivers. Estuaries is around 1.44 million hectare. Regarding to ponds and reservoirs, it is from the recent census, it was enumerated as more than 24 lakhs water bodies are there. Ponds and tanks contributing over 2.36 million hectare. Reservoirs is 3.515 million hectare, and wetland is about 1.2 million hectare. So we have a vast water resources. Let's have a look at our fisheries conditions in Indian scenario. So India has a very good stand in the global aspect, global level. So India ranks third largest global fish producers, and it is contributing 8% to the global fish productions. In aquaculture productions, it is second largest global producers, and in inland fish productions, it ranked first. So we have a very significant stand at the global level. So let's have a look at fish productions at the national level. So India is producing about 16 million metric ton fish productions. So among these, marine is contributing about 25%, and inland fisheries is contributing around 75%. Coming to the exports, the quantity is about 1.44 million metric ton, and its value is cost around $7.7 billion US. For gross value added product of fisheries, it is costing it cost around 30 billion US, and for national GVA it is around 1.24%, and agriculture GVA it is 7.28%. And if we can see from 2014 to 2019, the annual growth rate is around 10.88%. So from these two aspects, two scenario, we could say we have a vast water resources, and India has also have a very tremendous growth in the fisheries sector, but still there is a gap because we have a high expectations for the future, and we have to stand at the national and the global level. So for this, there is a very different challenges are there. So one, it is reported that we have a vast resources which are underutilized and unutilized. So that we have to address how we can manage those underutilized and unutilized water resources to get the more productions. Since India has already a tremendous growth, but still the production potential of all the water areas are yet to be realized. So in that address, in the recent modern technologies can play a very big role for precise management and monitoring of the water bodies and the fisheries productions. So that aspects will be delivered. So all of this, there is a various challenge that all the fisheries sector, they are facing day-to-day life. So that challenges, that will be covered by Dr. B.K. Das. He is the renowned scientist and has more than 30 years of experience in the field of aquaculture. So he will be explaining in more better way and more interesting way. So I'd like to request Dr. B.K. Das to continue with the talk.
As you know, the challenges are huge because it is not a land animal, it is beyond the water. So any technology, anything you develop, it requires more refining. Today, you may have maybe drone-based system or maybe underwater robots is a more important to look into the migratory and other part of the things or behavior, everything. But whatever underwater robots has been developed elsewhere in the globe has a different advantages or disadvantages. And if you treat the challenges in aquaculture, if you see the resources are huge, but if you see utilizing resources and has a production potentiality is a challenging task. Again, if you see seed, feed, and disease, these are three major challenges where needs the attention and use of the technology of this system. And if you look that besides that, we are today the climate scenario is a big aspect because shifting of the breeding cycle, productivity, disease, then we available to the species in a water, open water resources is a major challenges. To again, if you look into the another systems, if you go to the high productions efficiency in any of the aquaculture ponds or the shrimp culture ponds, you had required lot of devices to the monitoring, starting from the oxygen, ammonia, pH,
all these things, it should be the IoT-enabled systems. And looking into the system of these things, if we'll see the different government initiatives we have taken from the different aspect. Honorable Prime Minister Matsya Sampada Yojana is rightly placed, looking into the doubling of the productions, maybe what is the target by 2025 is a present level of productions, how to address with the technique use of the IoT based technology or the different systems of this, and which maybe Kisan drone facilities are available in the different KVKs, research institutes to work upon these things, or maybe if we'll see that network projects where the NEPA were the partner, where building of the robust standardization techniques of the different monitoring devices, which can be implemented through different stages, or you may see that we have the per capita consumption and how this is the things, maybe 60% of the fish eater, and still the demand is huge, and you have a maybe the quality assurance, and all these systems we require the precision systems that to be adopted. Then all these with three different maybe infrastructure, digitizations, and the automations, three things which can be required. And if you look into any of the systems, maybe a precision farming systems, we are bringing a precision fish farming systems, maybe with the model systems. Maybe I have given a cage culture, because cage culture in either maybe open water systems, maybe reservoirs, or maybe you go for the sea is required, because this is a small place where you can have intensive productions, maybe a cage of a circular cage of 16-meter dia can produce 30-ton fish. So for that we require all aspects from the behavior, disease, growth, maybe environmental parameters, which needs to be the monitored, and we are developing a prototypes how to go this type of monitoring systems, and that used to the precise nature in the different technologies. And another, if we'll see, maybe we are doing of the big data platform in the different aspect of the river, maybe hypoxic conditions, aqua life systems, different systems that are available, which can be lead to the decision support systems again. Again, if we'll see in the different ways we are monitoring the environment and the managing the environment also. Again, this is one of the conceptual architecture looking into the aquaculture underwater devices to maybe drone-based water sampling, or maybe seeing the chlorophyll, other things, maybe the productivity assessment, or if you can go to the water quality sensor integrating with the water sampler also, non-centrifugal systems, or maybe with a automated feed dispenser, which can be with a controlling in the different place of the time management and what are the demand feeding to these systems. And also imaging systems, maybe determining the different aspect of the vegetations and followed by the different aspect. Then DO control and these were the with the different systems we are predicting, and that will be the major things. And when the drawback is one of the bottlenecks we are achieving, I told, based on the turbidity and the other aspect, it is very difficult sometimes to monitor all these things. Again, we have to see how best our under camera which is placed, or all these things which can have a that can have took the turbid systems can measure the systems. And that I told initially, we can have a health, feed, water quality, and the harvest optimization that can be in the systems. Again, if we'll see, we have some of the water quality systems. I told DO management systems, it is under standardizations, and we have developed, and which was in displayed outside, you can see. And these were the system where maybe energy saving, one of the systems, you can have a time system which aerator can be start based on the optimum DO level set 4 or 5 ppm, and then it is a different time instead of hypothetical going for the different time intervals. Or sometimes if your DO levels falls below 4 ppm or 5 ppm, whatever the level, then automatically you can have aerator systems, or you have not these systems, you can ask somebody to person where they can start the aerations. So totally you can have energy savers, and that can be taken. And gradually we can have that maybe add to this system, the cyber security, other things, but it's the first line of development where you can have cloud-based, and the system we can work on this. Again, we are also working of the health management with the underwater robots, but one of the challenges here, when the underwater robots moves, that it gives something, so fish they avoid to that since capturing image is very difficult. Again, we have to see what are the refinement required on these systems, because we are integrating with the source available in the outside to the current system. There are several changes, but still we are working and optimizing these systems. Again, we have a smart technology of the feeding systems where we can at a time address here the 4 to 5 cages, and that can feed if we put in on the platform of the cage, and equally 4 cages will be fed. So instead of one cage going to other, so you can have that can be addressed with these things. And this automated feed dispenser may be different institutions are also working, but we have mostly working on the system that is operated in the cage systems, maybe large circular cage in the different ways, less time, everything. Again, we will see harvest optimizations, maybe today, maybe post-harvest loss is more than 20% everywhere, and the different size grades and other things which can be minimized, and you can see that a particular graded fish have the fetching the market, and the quality assurance can be assured with these things. And from here you can predict the growth post-harvest based on the things, then maybe market price you can based on the things. Again, besides that, you can have a disease outbreak, I can manage the disease, then plan to harvest, predict the mortality is also, how much mortality is happening, then what are the returns can be done from that. And finally, the stock assessment of your product. So again, we are doing the drone-based technology in the remote place, in the river and other way. Sampling is very difficult, so we have a sensor-based water samplers which can add to the systems where you can go for the different ways, different terrains, difficult terrains to collect the water and analyze for the different purposes. Then we have the drone-based macrophyte also. We are working here, and spraying also. You will see controlling because we have Weed Institute Jodhpur have developed some of the methods which can control the weeds, and you can assess the things, and you can spray to control the weeds also in the different large water bodies where controlling of the weed is very difficult. Then we have monitoring the underwater health of the fish behavior. Then we have the monitoring in the different CSR institutes also monitoring the coral reefs in the different cases. Again, you have these are some of the initiatives we want to see in the future way of integrating the smart aquaculture things, which maybe it's a time it is taking, but still we are hope that these things will be can be incorporated for monitoring and giving a precision farming in aquaculture sector. And thank you for the patient sharing. I will hand over the next to the animal science group. Dr. Mohanty, please.
Good afternoon. So I'll be talking about animal science. Though we are the first in the world in milk production, but the number of animals which are producing the milk is too big. So our challenges are because of this greenhouse gas production. So we have to think of how we can improve the productivity of the animals. Without smart technology, we cannot do this thing, because we are trying for so many years through artificial insemination to improve the productivity of animal, to reduce the number of animals required for productivity. And our demand for milk is also increasing. So I'll give you the data. We have been increasing, we are increasing in the milk productivity, but it is not that much. Our growth rate is around 5.89, and our per capita availability also increasing. It is higher than the world standards. But still we need to produce, because we are not net consumer only. We are not able to export our product because of global standards. So if without this thing, we cannot produce our milk, the quality which is required for exporting these products from the milk. So that is a big challenge for us. So these are our animals numbers are huge, 302 million bovines, means including cattle and buffaloes. And these buffaloes are producing much better than our other animals. Their productivity is good, and though the number are less, they are producing more because exotic cow and the crossbreds are increasing because of their higher productivity. And we are neglecting our indigenous animals. They produce quality milk and the demand is also there, but their productivity is very low. So we are, Government of India now adopting a lot of technology. Artificial insemination is there, then ET, IVF technology to replicate this high producing animal at a higher rate. We are trying. Still, the major problem is our animals are scattered. 80% animals there in rural, and hardly 4 to 5 animals are kept in one household. So the technology reaching to them is a difficult thing, and commercial farmings are coming up. Commercial farmings are coming up. So this, our main thing is that once the commercial farms will come, they can go for genomic selection or progeny testing programs to improve the productivity of the animal. So, but the commercial farms require technology. Still now we are importing all the technology from these developed countries like GIA, Westphalia, then D-level, then your FE milks, all Israelis, Denmark, and all this technology. But the cost is so high, the return out of ROR is very low. So people are not adopting. Very few research organizations or very big farms, they are adopting, but the other people, they are not able to adopt. Without this technology, it is very difficult to manage the animal productivity. So the major thing is that performance recording. We don't have our animals identified. The first challenge is our animals are not identified. Hardly we have now 5 to 7% animal being identified with the enough system. We have not identified animals. The farmers, they have a name to this thing. Now, Government of India, our Prime Minister has put this thing that we'll be having Aadhaar for every animals, means animal Aadhaar. So this is the technology is coming up that animals will be and the small ruminants, they will have a group of flock Aadhaar. So such type of things are coming up, and huge sum of money we are putting to this thing. The identification is a major challenge. Without identification, other technology cannot be adopted. So this, for all these requirements are required for health management, productivity, and genetic improvement. So these challenges why we have large number of breeds, and they are because of our agroclimatic zones, they have different type of animals. We have near about 54 varieties of animals in bovine, and their production level, all these data are different. So if you are developing any standards, you have to develop for each breed. So that is a big challenges. Okay. So then we have cow and buffaloes also. They are completely different, their physiology and all these things. Though they produce milk, but their physiology is completely different. And buffaloes work, mostly these South Asian countries are working more in this thing. But our major production of milk is coming from 50% milk is coming from our buffaloes. So we don't have any type of IT tools which is reaching to the farmers for collecting such type of data. So that is a big challenges because we have around 302 millions of animals, and their data to be collected is a very big challenges. Or need a lot of money to do all these things, and they live for around 10 years. Around expected life is 10 years. So you have to keep this data for 10 years, every animal, then how much you can think of. So this is a big challenges for us. But if we can do at least 50% animals to be recorded and their data to be analyzed, then our productivity can increase faster. That is the things I want to give you. We are very late because the country, those who have started their data recording, and we have started from 2015 only by enough system. So we are late, but we are going in a good space. So when you talk about performance recording, so then it is come with increasing information, increasing complex decision, because when your data is more, your decision can be taken, but that requires different statistical tools to analyze this data. So a professional approach to the management. If you need a data, then only you can get information out of that, or you can leverage knowledges out of that. So this is a big challenges for us. So it is very in a nascent stage. Only research organization and few dairy farm, those who are imported this system and put into this thing, they can do. And the expertise people are not available to analyze this data. That is a big challenges for us also. So we are doing such type of small researches for our animals, because our NDRA, we have near about 5 breeds of cattle and 1 breeds of buffaloes. So we collect all this data, calf growth module, because our calves are the major future stocks. So if you are able to forecast that at what rate this, if you are taking every week or half monthly, means 15 days data of body weight only, and you can forecast that whether it will become a good cow afterwards or not. Similarly, we have lactation calves. We know this thing because the milk is a 305 days milk yield. It goes increasing up to around 80 days. Then it will be remaining for 180 days. Again, they will come down slowly. So if you have a lactation calf standards for each breed, then you can predict a lot of diseases if the lactation calves get modified. If you're data collecting every day milk yield, you can predict all these different diseases, which can be remotely can be predicted. A farmer is giving the only data of milk yield morning and evening, or you can collect this data, then you can model them to say this thing, that what are the things happening. The next point is that we have a large number of animals. We are the largest artificial insemination system in our world. We are 122 million doses of semen we are producing, and we are inseminating near about 79 millions of animals every year. But our penetration is only 35%. We are trying to make it 50% so that our semen productivity has to be increased. And the success rate is only 35%, which is a normal is around 50% animals should conceive to a single artificial insemination breeding. So that is a challenge. So heat detection, because if you are not able to detect the heat right time, you are not able to do this AI right time. So technologies are coming up, that wireless sensors technology is there to collect this such type of data. We have done with IIT Delhi, this speedometer we have developed, and we can do this. We have done this thing, and the success rate is, you can see this thing in estrus, the animal is increasing their activity by around 200%. So we have, for our indigenous breed in our climate, we have found out that what is the right time of AI, you can do these things. So these are the algorithms we have developed that for increasing the conception rate. So these are the mastitis is another problems. So mastitis also, we are doing this thing that EC and pH of the milk, if you are collecting continuously, then you can predict the animal, and it differs from different season and different breeds of animals. So there is a big challenges, because we are not having one breed. We have multiple breeds. We have to develop technology, and where climate is also effect in the EC and pH. So we have done this thing, and a fuzzy logic based system we have developed, which can be very handy. It can be applied, it can be used in smartphones and other things to develop such type of things. So these are other models also, CNN models also we have developed for detecting the mastitis. Then comes now, because mastitis, one thing is that you have to sample and do this thing. Now this IRT, we call this the infrared thermography, is coming up because it is a handheld device. We can take the photographs of the 4 teats, because all teats are separate entity. Mastitis can happen to any one of these things. And this data we have collected for their, confirm them, and we have developed the algorithm to detect the number of animals, those who are having mastitis. And this model is working very fine with 90% accuracy and sensitivity. So this is a climate control, because our climate is very tough in summer to manage this reproduction. So we have to manage this humidity and temperature, because THI is the major factor we use as a comfort zone around 70 to 80 degree, 18 THI scale. So these are the things we have developed, that how we can fanning and the misting can be controlled. For here is Dr. Sanat is there. He was our one of these collaborator at that time. They have developed all these things. So this is a smart drinking kiosk, so that when the animal is coming and how much water is taking, we can collect this data to find out that animal behavior. So this is a smart bucket we have developed. The EC and pH, it can be collected by this system, weight, EC, pH, and it goes to the server, and it can predict the animal which is having a different stage of their mastitis. We have used this thing. So then we have vocal cues, because every animals, just like human being, they used to talk to each other, and they are in different physiological conditions. They produce different sounds, which are different, which are very specific to the particular physiological conditions. Then comes your another problem, say our foot lameness is a major thing. We are, because housed animal, they are tired. So they used to develop a lot of foot problems. So this IR-based camera we have developed, that yes, it can predict 10 days before this animals is coming towards things, and we can treat them. All management systems are available. So this is another thing, is that we have different breeds, how to distinguish. I'll 2 minutes. I'll finish. Yeah. Yeah, finish. Okay, okay. So we have, this is the last thing. So we need a lot of sensors. So it can be wearable, because animal is moving. So the sensors require for all type of animals' behavior to be recorded, can be a path breaking things. Now only maximum this activity meter and pedometers are being used, others are not in the market. So there is a lot of research is required to collect the animals remotely, all this data, and in a small villages, the village can become a virtual farm to collect such type of data. Thank you.
Thank you, the speakers from ICR. They show us very rich use cases for smart technology in aquaculture and livestock farming. That's really impressive. Because limited time, we cannot go into very detail. Thank you again. Then the next speaker is Dr. Saraji. The printed title is Digital Agriculture, Some Perspective on Standardization. Please, Dr. Saraji.
Thank you, Chair. Esteemed panelists, and greetings to the August gathering and the audience here. I represent Tata Consultancy Services, and I think it's been a wonderful day today, a lot of interesting sessions. And while I was listening to the sessions, and especially the concluding remarks of the previous session, where Dr. Jha was trying to summarize, and the speakers before me, I was just thinking that within the Tata Group, when we take up especially large, ambitious projects, there's something that we put through the 3S test, which is simplifying, synergizing, and scaling. So there's a 3S of simplify, synergize, and scale. So I was just thinking that probably here we need to do simplify, synergize, and scale through standardization, because when you actually bring the standardization, that is when you're truly simplifying, because you have well-defined interfaces. You are synergizing different players who can work together, and you're scaling up because you're defining something that can be adopted at large. So with that, I will start off. So a bit of my background, of course, Dr. Manti, thank you for showing up that picture. That was me about 10 years ago. So I have a background in technology. I did my PhD from IIT Delhi, and was fortunate to listen to some speakers also from IIT Delhi. So I've been part of ICR since the NAIP times. So I can call myself as an insider of sorts, but I still feel that in this session, I need to play, and we all need to play the role of a devil's advocate, wherein we have done things, we understand things, but we need to look at it through a critical lens and see what are those areas where the lack of standardization or things that could be done better will actually help to scale those things up, right? Beyond proof of test, proof of pilot, proof of concepts, and so on. So I'll try to do that, and I don't have too many slides, but I'll try to give a flavor of that through certain activities that we've been doing, and what we've been realizing, and how we've been contributing. So let me go to the next one. So there's a brief about our group. Simply put, we're part of what was erstwhile MCRISHI of TCS, which has been there for almost 15 years. Some of us would know about that. Our group is now called the Digital Food Initiatives Group. And what we do is we keep the farmer at the center. And when we say farmer, since the group started in India, it was largely the smallholder farmers. So we understood very early that we need to create farmer producer organizations and facilitate cooperatives so that we're able to impact them through technology. So in fact, TCS being a technical organization, it itself took up the responsibility to set up FPOs in Maharashtra and Tamil Nadu to actually start informing policy decisions. And with that at the center, we have the ecosystem, very familiar. We have the input companies, the seed, fertilizer, pesticide, equipment manufacturers, and all those that come in and help the farmer from the pre-sowing to the post-harvest phase. And then, of course, on the right, we have all the export organizations, processors, and other industries that come in. And since we work across the three realms, crops, livestock, and fisheries, so all these apply to those as well. And on the top is that's where ICR plays a major role, wherein we have government agencies, extension centers, and essentially the policymakers and decision makers there, which constantly try to see how things can be done better. And standards are going to be, and recommendations are going to be a very big part of how that actually happens. And as I mentioned, the bottom is actually talking about the entire agri value chain that we have in India, which is at the crops, livestock, and fisheries. Having said that, as we speak today, we have our Precision Ag platform deployed across multiple countries. So some of the things we'll be talking about is also from the learnings and the things that we have seen, not just in India, but across other places as well. So what we do, we essentially do 4A. 4A is acquire, analyze, advise, and actuate. So the first A is where we have data at multiple levels. So I'll not spend too much time. You've heard of this. We have data at the ground level and at the sky level. And what we essentially try to do is we try to do a convergence of sky and earth technologies where farmer data, crop data, soil, sensor, drone information is merged and synthesized with satellite information, even on ancillary data like weather data to generate insights. And that's where the analyze comes in. We generate insights, and the insights are then fed into the advise and actuate, wherein the different stakeholders around the farmer come into picture, and farmer himself is a stakeholder, himself or herself is a stakeholder, where they are getting the benefits of the advisories, and the ecosystem is also informed to start intervening at those critical points in terms of where they can actually help the farmer in certain ways. For example, input companies would like to know when to place their products, how to supply seeds. Similarly, equipment manufacturers would like to know when the harvest is going to happen, so that pooling can happen also if required in the Indian conditions per se. Right. So what at least I try to do is the 4As, we've tried to open that up and put it in the form of a stack so that we can actually take a critical eye and a critical look at the different layers that we have and see what are those places where things are fairly good for whatever reason, and things where there are opportunities for standardization. So if we see very simply at the bottom, we have soil, climate, farm, crop, and operations, right? The fundamental data blocks. And there's some detailing to that in the sense that, for each of these data points, there are multiple different ways in which you can actually get it. You can have multiple soil databases, you can have soil scanning equipment, you can have soil sampling strategies. Similarly, when we talk about climate, we have weather databases, we have specific weather providers in different geographies. You may have to actually have microclimatic conditions captured in different scenarios, right? So just to give a sense of this, even as we speak, we are supporting projects in India and in Middle East. Now, in the Middle East, 70% farms are indoor farms. So it's very heavy in terms of indoor farming, greenhouses, vertical farms where you need to have sensors deployed, and a lot of things that come with it. Whereas it's a lot more open when it comes to Indian scenarios in general. So we have to keep these concerns in mind when we're actually designing our systems so that we are able to have consistent interfaces when we are catering to worldwide audiences. Then, of course, as we move ahead, we have the farm and the crop part from pre-sowing to post-harvest, and of course the operations, all the standard operations, soil, inputs, irrigation, and harvest practices, and so on. So that forms the data layer. And if you look at the acquisition modalities, so I've tried to group them in 3 buckets. One is the satellite remote sensing, the intermediate sensing through drones, and the ground sensing, right? And we'll quickly go through these layers, we'll work our way upwards and just see what are the areas where some things have been done, and there are areas where you're trying to contribute to make it more seamless. So if you look at the first part, which is the data part, so the data part is this was one of the interesting projects that started in IIT Kanpur, where the Agropedia project actually helped to structure the crop information. And I think that was one of the interesting starting points to have knowledge bases capture a lot of information in a structured fashion so that they become queryable, usable by multiple different systems. And now all the AI systems that come in place, which build on top of it, and a lot of Gen AI and other things that are coming up, they actually build on these fundamental knowledge graphs. The second picture is actually something that we have set up in, and we are setting up in our TCS centers as well. Of course, we work with multiple farmers, but we consciously try to do charity at home. So we actually set up demo farms within TCS campuses and do very intensive IoT-based monitoring of crops. So this is one of the farms that we set up back in 2017, where we started with 2 horticultural crops, cabbage and capsicum, and intensively monitored them for about 42 different parameters using 14 different sensors, which included multiple levels of soil depths. And we do this exercise to put our capabilities to test and also try to evolve them. But what I'm trying to say here is the climate becomes a very important part, whether it's the microclimate or it's the weather in general. It becomes very important to standardize and utilize it in a consistent fashion, because we have seen very different scenarios even within the same crop in different agro zones within the country. So to give another example, we talked about greenhouses and open scenarios. If you take a crop like tea, now tea in Northeast grows in open conditions, whereas the same in South India has a very hilly terrain. So the assumptions for climate or microclimate for tea, which may be good in, let's say, Jorhat region or the Tinsukia region, may not really apply when you're actually doing things for Munnar. So you have to be, very careful in terms of how you're designing a system so that you're able to scale even for the same crop in the same country, but in different agro zones. Coming to the other part, then in the remote sensing part, so the good thing is that with remote sensing and GIS, there has been good work in terms of standardization. Started off, I would say, with the shapefiles that were started off with ISRI taking a lead role in terms of building up ArcGIS and trying to see how we could process this. And then a lot of other consortiums and groups coming into picture. That's where, if you look at the data formats, I've not highlighted shapefile because the more focus in terms of standardization is happening towards GPKG, KMLs and all. And that's where with standardization, what's happening is even the limitations of earlier formats are being taken care by the later formats that are actually able to accommodate a lot of variations. If you look at metadata and GIS services, in metadata, we have ISO playing a role. And then in terms of GIS services, again, the Open Geospatial Consortium is playing a very good role in terms of defining all kinds of services, whether it's a web mapping service, whether it's the WFS service and the other W-oriented services, which actually take care of all kinds of GIS services, tooling, exchange, and makes it simpler there. Now, along with this, what we thought is, while this is something that's useful from a remote sensing perspective, which also to a certain extent is then leveraged by drones to represent that information and build up those layers, and also by ground vehicles in terms of what we scan and try to decipher a lot of knowledge from. But there are specific problems that come into picture when we actually start looking at UAVs and drones and different crop specific concerns. So that's one thing which I've tried to highlight here. For example, when we're actually trying to find infestation of pests or diseases in a certain crop, a lot more decisions actually come into picture in terms of to be able to actually understand the level of infestation, because depending on the nature of infestation, the morphological characteristics, you need to control a lot many parameters. So these are open questions. Now the question is, can we actually use this as an opportunity to standardize further, right? So you actually have a fuller play here. So this is just a research paper that we published. Now, moving further down, if you look at the ground, there, again, a lot many things are there. The good thing is that with IoT and sensing in general, a lot many standards are already at play. Now, the question is how to bring those things together in the best possible way and see how you can actually leverage the best of the standards, for actually building up scalable systems. So this, again, a view of standards that are coming in terms of the local area network standards, which include Wi-Fi, Bluetooth, Zigbee, LoRa. The more important thing is that some of these, which are more popular in personal area space, may not be all that popular when it comes to the agriculture, specific scenarios. That's why earlier in the day also we heard LoRa WAN being used because of the long range. You can also make do with smaller message packets, but you actually need a longer range, which is important from an ag perspective. At the same time, if you have handheld devices, maybe some of the personal area networks become more attractive. So there's protocols which are used even in the home industrial space. They may not as is be applicable, but there may be other protocols that are more attractive when we look at the ag space. Then moving to the wide area space, of course, ITU is doing a lot of work in this, so I need not elaborate on that. We have the entire 3G, 4G, 5G, and then of course specific protocols like Sigfox that have come into picture, and standardization of the message interchange formats in terms of the HTTP, MQTT, and MQP that come in. But the interesting part is that when we're actually trying to deliver projects on the ground, which is IoT based ag projects, and especially in countries where regulations are very strict, because we also done IoT based deployments in other countries. There are a lot of other things that also come into picture. So I'll touch upon that in a bit. So it's much more than just these standards. And one aspect of that is mentioned at the bottom, where we're talking about the security of the payload. So the security concerns also start coming to picture. So I'll give a very simple example which will resonate. Normally what we do is when we're actually doing a handshake in IoT, we try to create a symmetric key. And we say, okay, you fix the symmetric key and you use that key to send your data, right? That's a very common way of interchanging. But when you're actually doing production grade deployments, you may, in fact, even for IoT devices, you may actually have to do CS certified exchange. So you may actually have to do advanced encryption standard based protocol that actually secures the envelope and uses a CS certificate to do the exchange. The way you would actually work on your browser, using a proxy in your enterprise, right? So those things also come into picture in certain scenarios. Now moving up, so if we go back to the stack, we looked at the acquire part. Now the middle layer is the analyze part. So analyze is where everything from crop suitability, nutrient requirements, conducive growth conditions, on to harvest readiness, and then also keeping the sustainability piece, the carbon footprint part. All of that comes into picture because invariably we are seeing that every project and every piece of work that we do, there is a sustainability piece that is coming into the picture. And every enterprise wants to actually be sustainable in some form or the other. So if you look at that aspect, and then going back to this, I just try to put two scenarios here. The first one is, let's say, something around crop stress detection. So we also heard some examples around this. Now the question is, while we have certain functions that come into picture in terms of having some data, sometimes not enough data, and you might want to augment that, then you may want to take it through a pipeline of models, and then you may want to give some recommendations around that. The question is that given so many crops, different variety of symptoms that come up in so many other ways, are there opportunities to find common patterns where we could actually do some standardization? So here also we're trying to create those use cases and scenarios to actually take the steps closer to that. Then coming to the second use case, which is the carbon footprint, and that's intentionally put up because this is one area where some amount of standardization is actually helping. So if you look at with the whole movement towards carbon neutrality certification, the whole scope 1, scope 2, scope 3 emissions need to be mapped out for an organization to be able to say that I'm actually neutral. And the PAS 2060 standard, which is the British standard, that's actually playing a very pivotal role in helping organizations achieve this. Now the question is that enough from an ag organization perspective, right? Now why is that important? Because some of these enterprises which are certified, they're not necessarily in the ag space. But the moment you have an ag production component, then suddenly you start having things like emissions coming from my crops, right? I need to understand whether my nitrous oxide emissions are beyond a certain level or not, whether my methane emissions are acceptable or not. The moment those things come into picture, you actually have a lot of work that's coming from the FAO space that actually becomes important. So the IPCC guidelines and the work that FAO does with IPCC, those become a lot of importance is suddenly comes into picture with respect to that and what it can do in terms of helping the PAS 2060 overall, right? So we should take the inspiration from that. So with that, so that's on the second layer. Then the last layer is the top layer, which is essentially advising and actuating based on all the information that we have below. And what that essentially entails is you have the farmers, then you have the ecosystem players, and you have all the services getting bundled up, let's say using farm management solutions, equipment and devices that the farmers use, and a lot of standards that come into picture. Now, this is just one example because there's a recent and a good initiative taken by the government of India in terms of standardizing the interfaces and having the UFSI interface in place. Having said that, even from our earlier experiences, we have found that having standardized mechanisms help a lot. So just to cite one example, a few years ago, we actually did the complete AgTech transformation for one entire country in the Middle East, where all the farmers in that country, they were onboarded on our platform. And because we actually evolved those standards, and naturally they're not public standards, but essentially ways that we evolved internally within the organization, the whole process was much smoother because you actually could create a playbook in a sense where you had farms with open fields, closed fields, a variety of greenhouses, different specifications in terms of sensors. But you will actually follow a playbook and actually onboard those different variety of scenarios very easily. So what I see is with initiatives like AgriStack and all that is going to also become simpler at a much larger scale nationwide. And of course, this is not the only initiative. We are seeing such initiatives across countries. Very recently, I've seen that happen in some of the work that we're doing in the North American region, especially in Canada. Even at the Linux Foundation level, there's work that's going on in terms of standardizing certain things. All these are going to help us. And of course, our work that we're doing through this workshop with ITU and FAO, I think that's also going to contribute a lot towards that. So with that, I'll probably take a pause. Yes, okay. So there's one last thing I wanted to just touch upon this. Now, when we talk about the ag stack, security is also a very important role there, and this is something that we cannot, just brush it under the carpet, because a lot of standards we see which have actually, come into picture as they would in the case of any other enterprise software development. So, for example, when you talk about IoT, embedded devices, and associated software, a whole list of standards from NIST, the OTA, ISO standards that come in terms of developing things for the device, ensuring that your ID is secure, your programming languages decisions are proper, and things from even black box testing, even things like the hardening measures to restrict access to the network, and also in general interoperability between the IoT devices. There are a lot of things that come into picture, which are often defined and audited, as part of the security precautions taken for the deployment. So yeah, with that, I would like to conclude. Yeah, thank you very much.
Thank you, Dr. Sarangi, for your very informative presentation, including the stack and architectural data and agricultural information. This and also the use cases is really a really good contribution to this standard. Okay, thank you again. And then we come to the last but definitely not the least speaker, Mr. Kumar. The title is Emerging Technologies, IoT and ICT for Sustainable Growth.
Thanks here, my colleagues on the dais. Good evening to everyone present here, and good evening, good afternoon, and good morning to all those who joined remotely this such a wonderful workshop organized by ITU FAO and hosted by ICAR, DOT, and TEC. Myself, Sushil Kumar. Earlier, I was working in TEC as a DDG IoT and now posted in Northeast and taking care of Northeast LSA. The 6 states which are mainly dependent on agriculture. I shall be speaking mainly on standards related to IoT and ICT. And as we know that Internet of Things, it is one of the most innovative technology being discussed across the globe to make to create smart infrastructure in various verticals, whether it is automotive, power sector, or the agriculture, aquaculture, veterinary, the waste management, water management, and so on and so forth. Large number of verticals and large number of applications. As we know, as per the projections of the United Nations, the global population may increase to 9.7 billion by 2050, and around 68% will be living in the urban areas. Then the land for agriculture will get reduced. In India, by 2050, around 60% of the population will be living in the urban areas. So we have to develop the smart infrastructure for the agriculture sector to increase the production for such a large population in India as well as across the globe. This it is also required to meet out the United Nations sustainability goals, like the goal number 1, no poverty; 2, zero hunger; 3, good health and well-being; 4th one, the quality education; 5th, gender equality; and the goal number 11, that is for the smart cities, not related with today's conference. These are some of the verticals and the smart applications: agriculture, livestock farming, aquaculture, food processing, automotive, all are related with the agriculture sector. In fact, my previous speakers, they have spoken about the aquaculture and the veterinary. In veterinary, we can use the biosensors. And ITU as well as ISO, IEC, JTC1, SC41, JTC1, SC42, they are working on IoT, digital twin, and the artificial intelligence. In ITU, the study group 13, as well as the study group 20. Study group 13 is on the communication technologies, especially cellular, and study group 20 on IoT and its application in smart cities and communities. So this energy governance, healthcare, education, they are also very important for the rural community. How we can provide the communication network to the last person in the rural and remote areas of the country and across the globe, and having the smartphones that will be very much required for creating the smart infrastructure that we will be seeing in the next slides. And this is one of the slides are taken from the ITU document, and starting from telephone to computers, and then satellite, mobile, internet, and broadband, sensor networks, data storage, and analytics. So IoT is a bunch of technology that comprises sensor network, communication technology, whether it may be the cellular or non-cellular, the artificial intelligence, machine learning, cloud computing, edge computing, multi-edge computing, and so on and so forth. Further, this is one of the pictorial view of the IoT functional architecture, in which we are having the devices, the network, and the platform. In the platform, we will be having the for controlling the devices, registration of the devices, and the data storage, etc. So these platforms are generally of proprietary, based on proprietary specifications. We cannot say them the standards. And proprietary development of the devices or the network or these communication protocols that is not good, and it will not be sustainable. It is therefore required we should use the open interfaces, the interoperable standards for the sustainable ecosystem, which may be long lasting. So this ITU is already working in study group 20 on IoT and smart city and communities. Then it was also having a focus group on data processing and management, and now the focus group on this IoT and AI for digital agriculture. So this platform is very important, and the security and privacy, which our previous speaker from TCS has spoken. Generally, the security is an afterthought. Once the devices comes in the market, they are manufactured and they are delivered, then the people generally don't think about the security. So these are the 5 challenges which have been shown by ITU, around 2017-18. The robust connectivity, the first, latency, availability, and the coverage and cost. If the data is not transmitted in time, it is of no use. Second one is the standardization. Third, interoperability and open interfaces, enabling platforms to talk with each other. In Horizon 2020 in European Union, they mentioned that they were having around 250 platforms across the European Union, and they were not able to share the data. In Horizon 2020, they created a project to develop the programs, how the data can be shared across these platforms. Now, 1M2M standard, which has been made as a national standard in India, that can be used, and the CDOT has developed the
platform which can be used by the various startups to host their applications and connecting their devices on those platforms. It will be to create the sustainable ecosystem in the country. Then security and privacy, that is really very important. If the devices are hacked, then those parameters can be changed. Even the spraying of spraying of fertilizers and other things, suppose the parameters is changed, then everything will be a waste. Then this importance of global standards from the interoperability point of view, it is very much required. We should participate in the standard developing organizations meeting, whether it is ITU or ISO, IEC. Then we should try to put our requirements in those standards. We should have participation. We should have our share in those standards, and we should use the global standards for the manufacturing, so that the devices developed in the country will also have the market outside the country. So this in Government of India, DoT framed a policy, National Digital Communication Policy in 2018, and it is already having the 5G, artificial intelligence, robotics, IoT, cloud computing, and M2M as some of the key features of this policy are mentioned. Then agriculture, smart cities, ITS, multi-modal logistics, and others. This 100 5G use case labs have been approved by the Government of India, and these are being provided for the research for innovations, startups, and MSMEs. Devices in various verticals can be created, and they can be tested through these labs. These labs will be further connected with the IoT platforms, and there the various applications can be created and tested. In TEC, started working in IoT domain sometime in 2013 and up to 2023, created 20 technical reports, which are more in the vertical domain as well as in the horizontal domain. So these documents have been used to create the policies. Their outcome have been used in the policies as well as in the standards. So one document, IoT, ICT enablement in smart village and agriculture. The 3 documents on related with the security, that is on 18th, 19th, and 15th serial number, code of practice for securing consumer IoT. Then framework of National Trust Center and Security by Design for IoT device manufacturers. These documents are quite important, and their recommendations have been used in the testing for creating the ITSAR by the NCCS, National Communication Security Center in Bangalore, and devices will be tested as per those specifications. 6 documents out of these are on ITU website. ITU recognized these documents as the important global resource for the global community. Then we participated in the development of these standards on IoT use cases, smart city use cases. And the third one that is very important for the rural community, IoT and ICT requirements for deployment of smart services in a rural community. And 4th one that is related with the IoT-based smart agriculture use cases. This next application of drones, AI, and IoT in cashew-nut farming. This IoT-based formulated surveillance system with disease detection in paddy crops. How we can use the drones as well as the smartphones camera for transmitting the images of the leaves, and on the back end, the algorithm has been developed, and the disease can be detected and advice can be communicated. So these use cases were submitted in the AI4A meeting, and these are the part of the document of the focus group. Then the IoT and ICT requirements in India, Government of India created BharatNet project for connecting the 0.25 million villages, and around 0.2 million villages have already been connected on the high-speed network on optical fiber cable, providing the 100 Mbps connectivity. This connectivity has been further extended using Wi-Fi hotspots, radio link, and this connectivity is also being used by the LPWAN providers as well as the mobile service providers. So in this way, the umbrella coverage is being provided across the country. And therefore, these devices can be used. Smart applications can be created. If we don't have the connectivity there, then the smart applications cannot be created. So in the rural and remote areas, we can provide the create the smart applications. So this is a pictorial view, and it is also the part of the Y.4218 standards created by us in ITU. This is the standard Y.4218. This major portion of this standard has been written by us, and the previous figure is also the part of this standard. So how we can provide the sustainable and cheaper network, low-cost sustainable telecommunication infrastructure in the rural and remote areas for the developing and the least developed countries. That is very important, because developed countries will already be having the network, but the developing and least developed countries, how they can develop the network using the ITU standards in a very economical way. So these all these standards are also the part of this common requirement and capabilities of a gateway for IoT, overview of smart farming based on networks, gateway functional architecture for IoT, requirement of a smartphone as sync node for IoT application and services, and then the ITU are related with the 5G services. Then 1M2M functional architecture related with the platform, and ITU TX.509, that is the standards of ITU which is being used for the security purposes, so that the devices cannot be replaced by the rogue devices. If somebody replaces the device with the rogue device, it will be a big challenge. Similarly, it's the standard cybersecurity for consumer Internet of Things baseline requirement. That is also very important. ITU supplement 76 use cases for IoT-based smart agriculture. So various use cases may be developed, but it is very much required how we can secure, how we can have the interoperable devices, interoperable network, and interoperable platforms, so that the data may be shared across various platforms. Then now, this is one of the very important picture taken from the UN Broadband Commission report released in November 2022. As per this report, only 2.7 billion people remain unconnected to the internet, even as on date. And these are, most of the people are from the developing and the least developed countries. There is a gap only of 6% in the coverage area, but there is a difference of more than 36% of the smartphones. If we are not able to provide the smartphones in the rural and remote areas to the public, then we cannot provide the smart applications. We cannot create smart applications in any of the verticals, including agriculture. So this advantages of using IoT and ICT in agriculture, most of the use cases have been shown, and we have seen the use cases here. Most of the use cases can be created. Like if you are having the soil testing devices have to be calibrated from the soil samples, and it may be different from one area to another area. So similarly, we can have the soil sample devices connected on LoRa network. We can have the gateway of LoRa network and connected on 5G, and then the drone with 5G connectivity can come and can take the data. Similarly, we can also have the devices on 5G. It will depend upon the economies of the scale which we want to have. Water management can be efficiently performed using IoT to reduce water waste. So such type of various use cases can be created, but we should have the secure and sustainable ecosystem across the country and across the globe, and we should be able to provide the remote smartphones to the people. Smartphones-based AI apps can be created, and these some of the apps are already working in the country, in Telangana and Andhra region, and this various pictures can be taken, and the AI algorithm can be created, and using those algorithms, the disease can be detected. Such type of use cases have been submitted by us during the FGAI for earlier meetings. Then in fisheries, healthcare, and teleeducation, these are also the areas in which we can provide the smart services in the rural community, and a number of standards of the ITU already exist. Then the takeaways from today's event, standardization, that is a collaborative efforts, and we should participate in the standardization meetings. It is very, very important at the national level as well as at the international level. ITU, we will be having the ITU meeting, ITU Regional Group for Asia Pacific meeting scheduled in April 2024. So I would request the Asia Pacific participants to participate in this meeting. Then the Study Group 20 meeting is scheduled in July. And similarly, we are having ISO IEC JTC 1 SC 41 meeting scheduled in sometime May, June. The people may participate in that meeting. The use of interoperability standards provide economies of scale, and the infrastructure developed will be sustainable for a long time. Some of these work items are already in progress, like the requirement and reference functional model of IoT-based smart forest firefighting system, requirement of IoT-based soil environmental protection and remediation, then use case of IoT-based smart aquaculture, and use case of edge computing-based Internet of Things. I would request the experts available here in physical as well as in virtual to participate in the work items, and submit the contributions so that the standards being developed can be used globally by all. Thank you. Thank you very much.
Thank you, Mr. Kumar. Share your insights on the using emerging technology for agriculture at national and international scale. This, I really like your points here. Thank you very much. Then we can do a very quick wrap up. For this, I really like to invite our speakers to do it together with me. So I will do some comments, and then I invite each speaker, just like Mr. Kumar did. So one sentence takeaway. So it could be anything, summarize your presentation or expectation or perspective, anything where we'll do the work. So in this afternoon session, we have very good speakers here to share their experiences on standardization for smart agriculture. As we can see from these presentations, standardization really, there are a lot of challenges, and also it is a bottleneck for further wide adoption of smart agriculture for better production, better profitability, and better sustainability. For this, we can say there are lots of things. We cannot do it alone. We must work together from different sectors, and not different like international organization, national institutions, and also private sector, non-government agencies. So that's really huge amount of work. We must do it together. For this, this focus group has already good start. We have some relevant there, and also ITU. Besides that, ITU and FAO already also have other relevant work. For this, we also need your contribution, and then we can do like our speakers do their one sentence wrap up. We can start from Dr. Singh.
Right. Thank you. I think, yeah, one sentence, one key takeaway from my side is that there is a lot of technology development that's happening. There is also adoption of that technology for agriculture as well. But given the context of agriculture, and particularly Indian agriculture, I think there's still a lot that needs to be done to ensure that's ultimately being adopted by most of the farmers. And I think that is a piece that we still need to work towards and bridge. But the efforts are huge and massive by many different kinds of factors. So it's equally encouraging as well.
For me, the takeaway would be a search and lot of initiative that as a national standards body I was unaware about. And what I understand is that a lot of things are happening in isolation. But unless until they are converted into a form of standard, then the implementation part may not be taken care of as effectively as it should be. So in order to make effective implementation of this smart agriculture initiative or the technology, the conversion of research or initiative into the standard need to. Thank you.
Aquaculture is a growing demand. So precision aquaculture leads to the smart aquaculture is important, for which the gates for the IoT based systems is more important and crucial at this junction, and should be properly well designed, validated, and useful for the farmers, and that can be implemented.
In my presentations, so the takeaway means in agriculture, that smart technologies and that has proved its importance. But in aquaculture, we just beginning our journey. So we have to do lot more to achieve our production potentials. Field we have to do more to get the potentials or explore all the technologies. Thank you.
Thank you, John.
In livestock smart or digital farming, the architecture standardization is required because it is a lot of data are collected. How this data can be consolidated and only information can be retrieved. Otherwise, the voluminous data which is collected, if you are putting the sensor, is a very big risk. And we have to see this thing whether these sensors are having any effect on the animals or not, because they will be wearing for 10 years. So that aspect nobody is talking about, but I have seen there are some concerns that what megahertz this data should be sent and all these things. People are talking about these things. There is not of standardization is required for sensors which are used for collecting the behavior data.
Thank you. So I think the key takeaway for me is interdisciplinary work plays a very key role in terms of furthering and pushing the boundaries of not just the standardization, but also in terms of developing the technology in a very holistic manner. And that is where even the standardization efforts actually make a lot of sense, because the document actually covers the perspective of every stakeholder and every viewpoint. It is then robust enough to be accepted and adopted at scale. So something that, and this is, I would say there's more cross-cutting, given that we work crops, livestock, and fisheries as well. And I personally spent a lot of time, at least in the livestock space and the crop space. And I think that we one useful takeaway from this discussion that we're having today. Thank you.
This IoT and ICT technology, that is the enabler for the vertical industries like agriculture, to participation of the agriculture scientists as well as the engineers and others from ICR is very much required in the standardization bodies. The use of the standard-based solutions that will be long-lasting and sustainable.
Thank you. Thank you, everybody. We still have time for questions. No? Okay, I'm sorry, so we ran out of time. So then I thank our speaker again in this stage. So for your wonderful presentation, although share your insights. So just as we just expressed, so standardization really need we work together. So a lot of work ahead. So, but we will walk ahead. Okay, thank you.
So special thanks to all our speakers and to the moderator. Thank you, Mr. Chen, for taking us through session 2. So before we conclude this session, I would like to invite the moderator to present the mementos to the speakers for session 2. So first we have Ms. Namita Singh, please. And I would like to invite Mr. Debashish Mahalik. I would like to invite Mr. Basant K. Das. Next, we will have Ms. Chena Jana. I would like to invite Mr. T.K. Mohanty. I would now like to invite Mr. Sanat Sarangi. And now we will have Mr. Sushil Kumar. I would now like to invite Dr. Anil Rai to present the memento to our dear moderator, Mr. Chen. So thank you to our speakers and to our moderator. We will now move on to the last section of today's program. So for the concluding remarks, can we have Mr. Sebastian Voss on the stage? And then we shall also move on to the vote of thanks. So Dr. Anil Rai, if you could also join us on the stage. So over to you, Dr. Voss.
Thank you. Thank you. As we bring the curtains down on a remarkably insightful and forward-thinking workshop on cultivating tomorrow, advancing digital agriculture through AI and IoT, it's a moment to reflect on the breadth of knowledge and the depth of discussions that we have illuminated this platform. This event, organized by the ITU, by the International Telecommunication Union, in collaboration with the FAO, and hosted by the Telecommunication Engineering Center,